you have to enter or exit while someone's giving a talk, please try to use the side doors, and maybe we can minimize that a little bit, make it less distracting. Also, a few people have asked about slides. We will be getting the slides up on the website. If you go to the schedule and click on any of the talks, that's where the slides will be. If you want to add your own slides to the website, you can see me and I'll show you how to do it through GitHub. Otherwise, I'll make sure that they get up there. Same with lightning talks. We'll make sure those are up there as well. I would like to also just read the list of the breakout sessions that have been proposed, and maybe we can get a show of hands so we know what size room to put them in. I assume one of the volunteers is going to be taking some notes with the hands, okay, so that they can organize that. So, number one, community diversity with the programming committee. If anyone's interested in talking more about that, can you raise your hand and let us know? Okay. Thank you. Web library IT accessibility. If you're interested in talking about that, can we see some hands, please, and keep them up there for just a minute as, okay, yep. See Kate Lynch has her hands raised. DevOps for lib. If anyone's interested in DevOps, please raise your hand nice and high so the volunteers can see. Okay, thank you. Can you see back there, or should I do the Dre method of measurement? Okay, all right. Metadata assessment. Anyone interested in metadata assessment? Nice and high. Okay, great. This is actually very even so far. Number 5, building a coalition of libraries running Tor. There's something something that's not legible after that, but, exit node. Okay, running Tor exit nodes. Okay, awesome. Number 6, ViewFind. Folks interested in ViewFind? Okay, thank you. Number 7, hashtag Mashcat. Okay, I don't know what that is. Maybe I should go to that. Number 8, Vivo/linked data/Git for data. Anyone interested in that? Nice and high. Okay, thank you. And number 9, archive space APIs and integration. Okay, anyone interested in archive space APIs and integration? Excellent. It seems like a fairly even distribution. That's awesome. Okay, thank you. One last thing before we start. I just want to announce some of our sponsors, and I also want to say, basically a big thank you to our partners. Without Concentra Event Management, really, this would be a disaster. On the contrary, it's going fairly smoothly. Yeah, nice and loud so they can hear you out at the registration desk. Also, of course, volunteers, lots of people running around, sometimes missing great presentations, to make sure things run smoothly. So just a nice round of applause for the volunteers, please. And then finally, I want to just read the list of bronze sponsors really quickly from the podium, and then we'll get started. So bronze sponsors this year: Villanova University Library, or I guess Falvey Memorial Library, Penn State University Libraries, Rutgers School of Communication and Information, the Princeton Theological Seminary, Ithaca, J. Store Portico creators, UC San Diego Library, Archive Space, DLF, Bywater, Nashville Public Library, Tri-College Libraries, Ninite Pro, Thomson Reuters, and the Cherry Hill Company. Thanks again to our bronze sponsors. And just so you know, the general sponsors have a sticker so you can identify them and you can thank them personally too, so as you're talking and mingling. So anyway, without any further ado, I want to bring up the first presenter, David Naughton. His presentation is Janus or Janus, Node.js handler for all library searches. He'll pronounce it for you. Okay.
How do I go full screen on the Mac?
You're right here.
Yeah. I don't normally use Macs. Great, thank you. Okay, can everyone hear me? It sounds like it. Hi, I'm David Naughton from the University of Minnesota Libraries, and this is my first code4lib talk. Excited about that. Thank you. And I am here to talk about Janus, or as Sean struggled a little bit, like people often do, pronouncing that. I have a coworker who's a little bit of a linguist, and he was sort of admonishing me for pronouncing it that way because he thought that was an anglicization of the original Latin. So I guess it should be pronounced Janus or something like that. So, but good luck with that. I think with people understanding what you're talking about. And I'm not sure exactly what's going on right now. Apparently I need help, so thank you for that. Okay, there we go. Okay, and so here the slides for my talk are online if you'd like to follow along. And this is, I'm actually a little bit surprised to be here because Janus actually is as you'll see, I think is a very small application. I think it really doesn't do much. And I've been a programmer for a long time, but even though I've worked in academic libraries for a while, I still feel like there's a lot that I don't know about academic libraries. And some of my coworkers suggested this idea, and I wrote this little application. They said, well, you should submit a code4lib talk proposal about that. And I thought, really? And apparently some of you find this interesting because the proposal was accepted. And so the problem apparently that a lot of us have is we have lots of different search targets for our library search forms, or just for library searches, excuse me. And this was especially a problem for us because you may have heard about our library data and student success project, and I've seen that there's a lot of interest in that sort of thing, gathering some statistics on uses of libraries and tying that to student success to demonstrate the value of libraries. And so we had this problem where we'd really like to be able to gather some statistics on how students are using the libraries, but how do we do that when the searches are going off to so many different places? And so one solution to that we've seen a great talk on already today is like a bento box style search, just one search form to rule them all. And one example is Quick Search from NCSU, which I think is a really nice project. I'm impressed with what they've done there. And I know there are others. We're talking about those on Slack. There's Jonathan Rochkin, I hope I'm pronouncing his name correctly, is mentioning his bento search, and I'm sorry I didn't link to that. And these are really nice, it's a really nice project, or a nice approach, but it may not meet your needs, and what if it doesn't? And so we decided to do something a little different, just take an inverse approach, and we have just one handler to rule all the search forms. And that's what Janus does. And now I have to apologize. This is, without question, the worst, most horrendous diagram I've ever created in my life. And I'm really embarrassed because so many of you have given such beautiful presentations. And I can tell a little bit of a story here. We actually are working on open sourcing Janus right now. But when I submitted the proposal, I thought I was going to have months to work on it. But then we were hit with like a surprise, critical, ambitious deadline project. And the deadline was right before this conference. And I valiantly, maybe unwisely, tried to get the code ready to release as open source before the conference. But that was a bad idea. And so I was frantically finishing my slides, trying to get ready for this, and that's the best I could do. But anyway, as you can see, this is the simplicity that the application really doesn't do much. Yet on the left, there is an example of some of the many search forms we have throughout, like our many websites, and then the search, and those are all the different targets corresponding sort of horizontally to where all those forms are going. And then what we do then, I think what's probably most interesting, I understand, to people, is that we have this one point where we can collect all that search data. And I know you may be wondering about that with respect to Kate Krause's talk, which was great, but wait for it, there'll be a little more about that later. So I think this has some advantages, like the bento box style does too, because in both cases we have a single code base to maintain, which helps to make it easier to protect privacy and enforce security. Fewer places to look for bugs, apply security patches, and just in light of what Kate was talking about, one thing I'd recommend. Something that we do is automate the deleting of that search data. And right now, Janus is just logging that data to text files, and we use log rotate right now to just automatically delete it according to just how long we want to keep that data. Okay. So another benefit that we got, and one of the things that led to this project, is that a lot of the targets, especially some of the vendor search engines, require us to construct some really nasty URLs. And this is one of them. And that's even that's like the simplest search you can do, really. And so littered throughout our code were URLs like this, where I think previous developers had just tried entering some searches in these vendor engines and just copied and pasted, and they were even worse than that. That's what I did for this project to try to pare it down and make it as small as possible. So one thing we did with Janus is we created a simpler URL API, if that's not too pretentious. And so now that's what a Janus target looks like, and we can give that to some web developer or designer who may want a special search form, just for their collection, and they're much more likely to get that right. Okay, so I'm running low on time. I'm going to have to go through this really fast. So I think actually, since the application is so small and simple, it's actually not that interesting to talk about that. So I'm going to talk about, and you'll be able to see the code when we open source it, but I'll talk about some of the challenges I faced in setting this up. First, we've done a lot with PHP in the past, and I wanted to test that these URLs were actually giving us some positive search results. And I tried to do that with the Guzzle HTTP client library, and I ran into JavaScript problems. There's some vendor search engines that required some JavaScript interaction to take place, and I just couldn't get it to work. So I thought, well, I've been wanting to play around with Node.js, so why don't I give that a shot? And then it worked. Everything was fine. Except, obligatory joke here, some people, when confronted with a problem, may think, I know, I'll use Node.js. Now you have an uncountably infinite set of problems. And so, challenges related to Node.js. That's the rest of what I'm going to talk about real quickly. So first one is just installing it. You may be able to use an OS package, but if your institution's like ours, your sysadmins may not like that. That's something unfamiliar. Even then, the version could be really old. So yeah, I use an installer. NDev is the one I use. There are some other ones. That's been an easy way to install it. Another one is that Node.js is not a robust HTTP server. Even though that's really what it does. You need a reverse proxy. Most common recommendation is Nginx. But again, you still need something else to keep Node itself running if it goes down, because it doesn't do that on its own. So people recommend like Forever or Supervisor. And that may seem daunting. And actually at UMN, there's a rumor I heard that doesn't surprise me, that OIT had explicitly stated we are not going to support Nginx. So our solution was to use Apache and Passenger. We already had Apache running. We were already familiar with Passenger. And there's a link to a tutorial on using Node with Passenger, and it supports it really well. One thing I ran into that even though the tutorial's pretty good, there are some things that are not documented that I just had to figure out based on what it does for Rails, including there are some configuration options in here that are undocumented, but I just tried them, kind of trying to infer what it would do, and it worked. Okay, and I have hardly any time left. I was going to talk a lot more about challenges with Node, so I'll really quickly go through some of this. A big one is asynchrony, and I thought that was not going to be that big of a deal because I've done functional programming before, and it's like callbacks. Yeah, I've used those. That's fine, but I was surprised at how challenging it was. So I'd recommend reading that last article there, and I'm almost out of time. There's a lot more information here that you can look into, and come and talk to me about it. Thank you.
Thank you, David. Okay, next up we have Getty Research Portal Reboot with Susan Lay and Adam Kayan. Thank you. Do you know where your slides are?
Getty _
Is it on the desktop?
I think it's on the desktop,
Okay.
yes.
Let's see. Oops.
There it is.
Great. Oops, not that one.
That one.
Yep.
So if I just hit play, it'll jump onto the...
Oh yeah, it should.
Okay. Okay, great.
Good.
Yep. There. Howdy. My name is Susan Lay, and I'm a junior software engineer at the Getty Research Institute. This is my first talk at code4lib, also just my first talk of any kind in front of people. So thank you for having me. I'm here today to talk to you about the new version of the Getty Research Portal, an application originally written in Solr and Java, which we are reconstructing with Angular and Elasticsearch. Let's see. There we go. All right, so some of you may be familiar with the portal, others are surely not. What is it? It is a metadata search aggregator, an online tool for providing access to digitized art history texts. It's comprised of catalog records of metadata with links to full digitized sources hosted by one of our 18 contributing institutions. Let's see. Okay. So because the cataloging for the books in the portal is performed by the libraries, which house the actual physical copies, its records are authoritative. In addition, the texts are free, downloadable, and entirely digitized according to international standards. The portal's contributions have grown steadily, and as its scope continues to expand, we do hope to include more resources in non-Western art. So if the portal has already proven itself to be a widely used application with extensive search functionality, why throw it in the trash and begin from scratch? One of the answers to that is maintainability. The original portal was completed before all but one person on our current development team even began employment at the Getty, and that one person is retiring in June. As you can imagine, the departure of 2 of the 3 original developers has considerably limited our ability to alter and enhance the code base without risking the possibility of catastrophically and enigmatically breaking core functionality. Now let's talk about design. The original portal actually looks pretty good, and it works pretty well. What you see here is the desktop version. Not bad, right? Now what you see here is the original portal on an iPhone. Now, this is a beautiful example of responsive design. Just kidding. I don't know about you guys, but I had LASIK surgery, so I basically have eagle vision, and the only thing I can see there is the logo. So as more and more art scholars and users in general do make the shift to conducting research from their mobile devices, the need for the portal to retain core functionality while also retaining a slick and intuitive user interface is crucial. And it is something that, as you can see in this side-by-side comparison of the old and new versions, we do feel we have slightly improved. So, what is AngularJS? What is Elasticsearch? Why use them? Again, I'm sure many of you are familiar with one or both of these, but I'll touch on the former very briefly. AngularJS is a JavaScript framework developed by Google. It is open source, so it can be freely used and changed by anyone. Also, the framework itself comes with a few key benefits and is hugely popular right now, so there is a large community of other enthusiastic developers out there working on projects. One of these benefits is dependency injection, which my colleague will touch further upon when diving into the architecture of the project. Secondly, one of the most useful features is two-way data binding. So this keeps the model and the view in sync at all times. A change to the model updates the view, and similarly, a change to the view updates the model. Testing is another area where Angular really shines. End-to-end testing and unit testing are both done very easily by the way the components are broken up. And for the appreciators of Model View Controller Framework, it is easy to develop your application in a clean MVC structure. Lastly, Angular is hugely useful for controlling elements of the DOM, using directives, filters, and other built-in Angular features. If you would like to see the plethora of websites and applications out there built with Angular, you can, and madewithangular.com has a list of some notable projects, including PayPal Checkout, Weather Channel, and healthcare.gov. Finally, Elasticsearch. How do you use it, and what have we been able to accomplish with it? Who's to say? Not really. In all seriousness, to dive into the architecture of the new portal and answer that question and a few more, I'm going to hand over the reins and introduce my colleague and the master architect of this project, Adam Cahan. Woo!
Cool. Hi, everyone. Okay, thank you, Susie. The Eagle slide, as always, is awesome. I'm going to first talk a little bit about our Angular architecture and kind of like start at the beginning of the app and then dive into our journey with Elasticsearch. Very quickly, we like Angular because it's popular, because it has a lot of structure. We like Elasticsearch because we're doing some other projects coming down the pipe with Elasticsearch, and we wanted to try it out because you don't have to use Java. You can write a bunch of funky JSON instead, and because it scales, right? With an Elasticsearch cluster, you can just keep adding stuff to it. So we decided to follow a style guide and design pattern for Angular that's been endorsed by the Angular team. It's written by someone named John Papa, who's basically an Angular guru and really well known in the community. The link is up there. I highly recommend checking it out if you are interested in doing an Angular project. The main thing we liked about this is the way that like services stay lean, controllers stay lean, stuff is structured in the project directory, and it just makes a lot of sense and takes advantage of what Angular does. Big thing, you can see we've got a couple layers to the application. The controller layer, which is attached to pages, a service layer, which this is an earlier version of the app a couple months ago, which has search service. Search service is our canonical source of everything search. Search results, search options all live in search service. When a controller needs to know what's going on with search, it talks to search service. When it needs to execute a search, it talks to search service. Search service then talks to a lower level service called data service, which interacts with all external resources. Data service builds our Elasticsearch query. Once that's done, that query is passed to Elasticsearch client, ES client, which is an even lower level service. So we have 3 tiers here. ES client actually uses the official Elasticsearch JavaScript client. Then that actually talks to our Elasticsearch cluster. So what we like about this is this architecture scales nicely, and if something changes at a lower level, it doesn't affect stuff at a higher level. Our application has grown. We've added a bunch more stuff, a bunch more pages. Sorry, I'm checking the time. And as you can see, the architecture holds. Search service is still injected wherever it's needed. We have a facet that opens up, a modal that opens up to look at all the different facet options for our faceted search. Search service gets injected in there. We have advanced search now. Search service gets injected in there. Our Elasticsearch query building logic grew so much we broke it out into its own service, which is kind of this lower middle tier. And we added a whole new feature. We want users to be able to save individual records that they're interested in and save searches. Right now we're using browser local storage to implement this, so we wrote another low-level service called storage service, which interacts with local storage, and then a saved record service, and we're using data service basically as a pass-through layer. The cool thing about this is when we create user accounts and have stuff stored server-side, I don't have to touch saved record service. I don't have to touch data service. If we write better tests than we have now, we're not there yet, and really mock our services with our Angular tests, we wouldn't even have to touch the tests, but right now we would. We would just create a new remote storage service at the low level, swap it out, change data service a little bit, and the rest of the application stays the same with regards to saving records. So that's the cool thing about this kind of architecture. For those of you who've seen it before, you know that this happens on the server side a lot too. All right, Elasticsearch. So with Elasticsearch, we did create our own mapping. This proved to be really necessary to implement a nice faceted search and also return MARC records for users. I'm just going to sort of walk through a search and talk about what Elasticsearch is doing. So I just searched for art. We got a bunch of results. You can see we've got about 32,000 records. We have our facet options on the side, type and creator. It's a little hard to see, but there are the number of records associated with each facet option. I'm going to go ahead and filter by creator. Now we're filtering by the American Art Association, excuse me. So our result set has shrunk, which is expected. We've also filtered our facet options. As you can see with text, under the type facet category, there's 523 results. Before there were tens of thousands. If you check out the creator facet, the facet options there do not get filtered. Originally, that would happen, but we didn't really want this, because then if I click on American Art Association, all the other creator facets just kind of disappear. We want logical OR behavior within facet categories so that if the user clicks on another facet option in creator, the result set actually expands. But then when I click on a type facet, the result set shrinks again. So to do this, originally we had one big Elasticsearch query with the aggregations, which gather facet options, as well as the filters that apply facets, that filter the search. We had to break it into 2 separate queries because in Elasticsearch, aggregations are scoped to the filters in the query. Right, our aggregations were getting filtered by the filters that were applied. So we have one query to get the actual result set and another query to get our aggregations. We then build a set of filters for each individual aggregation. So right now, for the aggregation that gets our type facet options, the filter says American Art Association or Metropolitan Museum of Art. For the filter that gets the creator facet options, it just says type. So that was one of the big changes. I want to give a quick shout out to our team. There are a bunch of us working on this. Our team lead was Josh Gomez, who's working on this for a long time. Also quickly, Alex Rossetti, who wrote a bunch of Python to handle all the crazy library data and convert it into MARC records. Thank you. Please talk to either of us if you have any questions.
Thank you. Next up, we have Dre Orphanides. Orphanides, okay. And he's going to talk to us about architecture is politics, the power and perils of systems design. Okay, you can navigate
I'm
this,
going
right?
to have to make the slides go. Why is my slides not open? History. There it is. All right. Oh, okay, we're not in extended. I'm glad to see this is not counting towards my time. All right, arrangement. Mirror, unmirror. All right, this thing. View. Present. No, that's not what I want to do. I want to do this with this, and then do this. Can I get the second monitor up, please? Over here. Over here. View. Presentation mode. There we go. Notes slide. Pause. Reset. Okay, now my time is going. All right. So a couple years ago, I was teaching a systems analysis class, and one of my students came up to me and he said, Dre, I was thinking that systems designers are in this really powerful position because the design of the system influences so much about what users can and can't do. And I said, yes, that's right. And that's why we're going to do a whole unit on design ethics. And he said to me, design ethics is a thing? Hence the alternate title to the presentation. Whether you're a web designer or a metadata person or a manager, you engage with systems design and you make ethical choices about design all the time. So what I'm going to do today is present 3 key lessons in the ethics of systems design. They're really more like uncomfortable truths that we need to come to terms with if we're going to design ethically. Lesson 1, systems design influences user behavior. Reading this, your reaction's probably something like, yeah, okay. Because if you can obviously control the user by constraining them overtly, right? But there's a whole school of design that's about encouraging the user to make certain choices, sometimes kind of subtly, that design that persuades the user rather than explicitly controlling them. So what do we mean by this? We're talking about design choices where we steer the user towards or away from particular choices that we might want them to make. This can be overt, as in the practice of disciplinary architecture. This is where you control people's behavior in public spaces through aversive design elements. Here, you provide constraints that don't absolutely limit the user's choice, but they aggressively discourage certain behavior that's considered undesirable, like the finials on this wall that prevent loitering, or these anti-homeless spikes. Design can also persuade users in more subtle and nefarious ways by exploiting cognitive biases to encourage users to make the designer's desired choice, even if the user doesn't intend it. On the web, these tropes are sometimes called dark patterns, and so here's a couple examples. Here's one from AVG software install, the notorious auto opt-in checkbox where the designer makes a possibly unwanted selection on the user's behalf. Another dark pattern on the same page, the checkboxes here represent a mixing and matching of constraints and affordances. Just one of the checkboxes, the one that's marked, is required and the rest are opting into optional services. So you have a constraint hidden among a field of affordances. The end result is that the user is likely to opt into more services than they really need, even though they might not actually intend to do so. There's actually so much devious stuff going on this page that I could spend an unreasonable chunk of the presentation picking it apart, but I'll spare you. If you're interested, see me later. Here's another example of a dark pattern. This is a fare search page from British Airways, and in this example, the designers are misleading by abusing visual cues to steer the user towards options that are not actually best for the user. So I'll zoom in. And you might notice that one of these fares is labeled lowest and has some color coding, but it's not actually the lowest priced option, right? I don't know how they think they're getting away with this, but there you go. Persuasive design can be used to benefit the user too. If you've used an ATM recently, to get cash out, you'll notice that it gives you your card back first and then gives you your cash. This is to help you prevent a post-completion error where you get the cash and your mind goes, okay, job done, and you walk away without your card. Early ATMs used to work that way and a lot of cards got lost, you might remember. So this is another example. These shark tooth stripes that you see on the road here, they get closer as the driver approaches a dangerous road segment, and so it gives a visual illusion that the driver is accelerating when they're not actually accelerating, but nevertheless they instinctively slow down. Even something as simple as a spinner on a page can help to alleviate confusion and frustration. And then for an example close to home, here at the NCSU libraries, we have several different search options, but we make the all one, the most comprehensive one, the default, hopefully to alleviate some confusion if the person doesn't know what the best place to search is. The uncomfortable truth is that design persuades whether you intend it to or not. So if you want, for instance, if you want people to click on links on your website, you need to make them look clickable. Here's a quick quiz. Which of the things on this page are click targets? I will leave that to you as an exercise. Calls to action, likewise, need to be in the area of attention or they're going to be missed. So this is a site I have actually occasionally shopped at, and when they did their site redesign, it took me like 5 minutes, literally, of looking around this page to figure out how to buy something. The add to cart button is pretty big, but it's at the bottom of the page and it's in a fixed footer, and so despite being pretty big, it's actually really easily missed. If you don't see it, it's way down in the bottom right behind someone's head. So here's an appropriately focused, appropriately constrained interaction. It's clear what information is being asked for, where the user is in the process, and how to proceed. Yes, I am complimenting ProQuest design. Don't get used to it. Design persuades, and this in itself presents an ethical dilemma. As we've just seen, design can persuade for good or for ill, and in intended and unintended ways. So here's a few principles to guide us towards ethical design. First, provide affordances and impose limits in a way that benefits the user. Second, ensure that users can recognize their current options. And third, if you're going to constrain the user, don't disguise that fact without a very good reason. Lesson 2. System design reflects the designer's values and the cultural context. Design is inherently political. This is something that came up in the keynote. This can be overt or subtle, and it can manifest in many aspects of the design process. So here's a fun fact. The New York Parkway system, as you may know, has infamously low overpasses. These were actually designed as a form of social control. By making the overpasses too low for the transit buses, the designers limited the availability of the parkway system to low-income users who couldn't afford cars. By design. This is an example of something that Mitch Kapor calls architecture is politics, design choices that act as a reflection of the designer's value systems. As we've just seen, this can be overt and deliberate, or it can be overt and just tone deaf. In 2013, a condo opened up in New York where all the subsidized units could only be accessed through a side alley, or a side door in an alley, and the full price units you could get to from the front entrance. And as we've seen, design can send a clear message about how designers value, or don't, certain users who interact with their designs. The names that we give to categories, the permitted values that we offer in a form field, the relations that we define in our databases all have political weight. Consider this simple example. Does your state's marriage license say husband and wife, or does it say spouse 1 and spouse 2? Your metadata schema is a social justice issue. You've probably all used an accessibility ramp at some point. Some of us may rely on them every day. Here's a perfectly serviceable, eminently useful example of an accessibility ramp. But what message does the ramp's design convey about accessibility as a concept? Is it something that's off to the side, secondary, an afterthought of necessity? Or is the message one of inclusion and integration into the mainstream? Your design choices reflect your values, even if you don't intend it. Consider this common problem in responsive design. When you switch to narrow view, you need to stack order your site features. So what goes on the top? What are your institutional priorities? Earlier, I complimented the design of this interaction here from RefWorks, but what does the information that's being requested actually have to do with using RefWorks? If you can't see it, they're asking for name, institution, and institutional role. None of the functionality depends on this information, but I can't bypass this screen without entering it. ProQuest requires that the user share this information because presumably the metadata is of some institutional value to ProQuest. They've chosen their organizational interest in collecting demographics over a user's potential interest in not sharing. The counterpoint to Kapor's architecture is politics is perhaps predictably politics is architecture. That is, your political and cultural context will influence your design. So here's a simple example from my neighborhood. This used to be a perfectly useful line of parking spaces, but then some local political squabble about property boundaries came up and a fence went up, resulting in fewer parking spaces plus a totally useless strip of pavement. If some system decides that your name is inappropriate, let's say it contains the wrong sequence of letters, you may find yourself blocked from participation. This is called the Scunthorpe problem after a town in England whose name frequently gets blocked from web forms for this reason. But then how do you provide your address? It's also possible for political influence to result in good design. The DC Metro map is often hailed as the triumph of design. This is due, at least in part, to the clever use of markers of local political significance in the design. It's got the Beltway, the Potomac River on it, and the county boundaries. For better or for worse, these boundaries separate and distinguish local communities, and so their inclusion on the map provides useful markers of social context. Here, the political impositions of the larger system enhance rather than limit the design. And once again, we have to come to terms with the uncomfortable reality that we are all of us biased politically and culturally. Our own perspectives influence our designs, and our cultural context inform and constrain what and how we can design. And to an extent, this is beyond our control. We can't avoid the influence of culture in our design, but by recognizing it, we can try to manage its effect. Here are some principles for designing ethically under the influence of politics. First, actively attempt to identify and recognize your biases and how they might be influencing your design. Second, design as to encompass users as universally as possible, not only in testing your systems diversely, but also by recruiting developers with a diverse set of skills and experiences. Finally, attempt to recognize what sorts of controls your culture or context might be exerting on your designs, whether explicitly or implicitly. Before we move on to lesson 3, let's do a quick review. First, we had systems design influences user behavior, whether you want it to or not. Systems design reflects your culture, your cultural context, and your values, whether you want it to or not. Implicit in both of these truths is our third lesson, which we'll state explicitly. The interests and values embodied in the systems that you design will sometimes conflict with the interests and values of your users. Consider, we often design by the 80-20 rule, which is also called the Pareto principle. It's a common sense heuristic that basically says you should exert effort where it's likely to have the most impact. So one key way that you can represent this notion is that 80% of your system usage is going to come from 20% of your users. Thus, the Pareto principle suggests that you should spend the majority of your efforts supporting those most frequent 20% of your users. But that means that 80% of your users are only getting 20% of your development time. What does that mean about the value of the majority of your user base to you as a designer? Another conflict that emerges, this time on the open web, it rises from the role of advertising in site funding. So if you're using a site that's a for-profit site, advertising plays a significant role. It manifests acutely in how site payloads are distributed between content and advertising. Some popular websites have a content to advertising ratio of about 1:5. That is, for every megabyte of article you download, you get 5 megabytes of ads and tracking JavaScript. What does this communicate about the value of the user relative to the value of the advertisers? Here's an interesting three-way interaction. To travel to the US, we have political structures that end up requiring traveler names to match your government-issued photo ID exactly, which is what it says on the traveler information form that TSA requires when you register for a flight. This particular traveler's culture provides identifying information in Arabic orthography, but the system designer arbitrarily limited the system to accept Latin letters only. What does this communicate about the value of the traveler in this situation? Once again, your metadata schema, or in this case, your data validation schema, is a social justice issue. Even with responsive design, which we brought up earlier, mobile views of websites often incur design compromises. Sometimes we give the mobile view less shrift because it's considered a secondary mode of interaction. But 15% of internet users are depending on their cell phone as their main internet access device, and 7% are wholly reliant on their phone. How do we ensure a meaningful, productive web experience for this population? I guarantee you that you have users in this category in your library or using your software, etc. Your mobile website is a social justice issue. Once again, these conflicts can't be entirely avoided. So how do we minimize their impact? Obviously, no system that we design can be wholly successful at satisfying every user all the time. Every design choice incurs compromises. But the important lesson to take away is this. When you make a design compromise, you need to be fully cognizant of its implications. With each choice you make, you should reflect on how it might affect your various user populations, even the most marginal. Recognize that this choice may exclude some user segment or make their life in the system more difficult. Acknowledge it up front, come to terms with the limits of your system, and then work to make it better. To do this, you must know the diversity of your users and their needs so that you can understand the implications of the choices you make. Finally, and most of all, make these choices with empathy. Reflect on the experience that you would want to have and strive to make that available to all of your users. Thanks. So I can't take credit for most of the ideas in this talk. They come from lots of different places, and especially the pictures come from lots of different places. So I encourage you to take a look through the credits, also read the articles that I linked to there. And I sent out the link to the slides on the media of different kinds. So I encourage you to take a look. Thanks. Questions? I'm not sure I'm the best. I'll do my best. All right. Thanks, everyone.
Okay, thank you, Dre. Next up, we have Sebastian Hammer with Constructive Disintegration, Reimagining the Library Platform as Microservices. Okay, do you know where your slides are?
Yes, they're somewhere on the desktop, yeah.
Let's do this.
Right over.
Click.
Yep.
You can probably just press play, drag that over.
Let's see, we've got the, let me see if I've got the percent of view thing going on.
Oh, good. That'd be great.
All right. Hi, everybody. I'm going to do something a little bit unusual. I'm going to talk about a project that we are involved in, a collaboration that we've become a part of at Index Data that up until this morning we didn't really speak about in public. It doesn't have a website. It doesn't actually even have a name. But despite that, we also felt that there was really no way that we could come here today and not talk about that project. So that's what I'm going to do. I'm Sebastian. I'm a co-founder, partner in Index Data. We've been around for about 22 years. We're a group of about 20 librarians and developers kind of confounding each other and doing projects together. Our particular focus over the years has probably been mostly on moving data around, doing systems integration, making systems talk together to support various types of ways that libraries might want to talk together and work together. And in doing that, I have probably spent a disproportionate amount of time in my working life, which is really all of my adult lifetime have been spent in this business, being frustrated about library systems, and in particular integrated library systems, which hold a lot of the data and the information that we want to work with in libraries and that are sort of gatekeepers of a lot of interesting things that we might want to get to. And there are places or systems or software that we might want to use to manage various bits of information that are important and various functions that are important. But they can be hard and difficult to work with. I was lucky enough a few years ago in 2009 to be invited to give a keynote address here at code4lib, which is one of the cooler things that I've done, I think, in my working life. But I felt frustrated afterwards because I think I groused about these issues and complained about them, as I do. But I didn't feel like I really had a lot of constructive alternatives to offer. I think at one point or another I said, I think we have to enable libraries to robots of interoperability to do more cool stuff. But I was very light on the implementation details beyond that. So I got, over the course of the last year or so, this opportunity to try to actually do something about this. And that's what I'm going to talk about today. So for background, the background for this story begins actually also in 2009 with the formation or the charter of the code4lib group of libraries. They came together with a vision to create an open platform, an open software platform in which libraries and software vendors and others could collaborate and work to build better software, better systems for libraries. And that vision was inspiring to me, and I know it was inspiring to other people, but there were certain issues in the implementation of that vision. One of the things that happened was that in putting together a system that could ultimately replace an integrated library system in the library, there was a lot of focus on gathering requirements and figuring out what those systems needed to do. And along the way, I think perhaps sight was lost of the platform aspect, this need to build something that was beyond or larger than just an ILS. So in fact, what they ended up with to a certain extent was yet another ILS, and that was an opportunity lost. Another issue that arose was that there was a choice made to use a platform and a basis for implementation that was cumbersome and that would make it difficult over time to attract people to the community to contribute to change and extend it. What did happen, though, was that code4lib, again, inspired people. They inspired myself. They inspired others. They attracted, amongst other people, EBSCO into their collaboration. EBSCO was looking for ways to stimulate innovation, to discover new types of services and activities that they could engage in, and they saw open source software, I think in large part because of code4lib, as a good way to pursue that. So EBSCO joined code4lib. They also contributed to the Koha project. And what happened then was that code4lib and EBSCO at roughly the same time came to the realization that the software platform was problematic, that something different needed to happen. So it was at this point that they approached us and said, would you be interested in having a collaboration with us to create a new platform based on the principles of the original code4lib project, but based on more current practices and something that would be more aggressively engineered perhaps to form the kind of community that was hoped for. So that brings us to our specifications. We were asked to create a platform that would be easy to extend, that would be actually fun to work with. And this is part of the specification that sold me on the project, because that's the sort of software that we like to work with ourselves. It's the kind of thing that we like to build. We were looking at something that would be licensed in an open way. So we are looking at using the Apache 2 license, so really inviting everybody from libraries to individual developers to commercial companies to come and play, work with the software, extend it, host it, do whatever they want. We wanted a piece of software that was designed to be cloud ready from the beginning, something that could be hosted in the cloud or locally in a multi-tenant mode so that a library or library network or a commercial company could host the system for many libraries at a manageable cost. We want something that was built around a knowledge base because we wanted to explore things that we could do in terms of providing better electronic and other types of resource management, and knowledge bases are seen as a key element of that. We wanted to explore how linked data could be integrated into the guts of a system like this to actually bring value, not to use it or employ it uncritically, but to look at real opportunities to make a difference. We wanted something, again, that could be hosted by commercial vendors, but also something that the library could stand up on its own. So we wanted to build the software to be hosted, for instance, on Amazon Web Services, but we are doing integration testing on a Raspberry Pi because it helps keep us honest in terms of scalability and in terms of modularity. And finally, we wanted to be community-based. So we wanted to really try to engineer and to behave ourselves in a way that would attract the most possible people and organizations and groups of people to this project. And I'll speak more about that. We wanted it to be modular. So we wanted to not just build another sort of monolithic system based around a known set of requirements for what a library needs to do. We wanted really an operating system, a platform in which you could plug in functional units that you needed, something that could be extended over time, something that will be flexible and could grow sort of horizontally and vertically. And I'll talk a little bit about how we imagine doing that. So we start with an empty box, and this is our operating system, our container. The idea being that this is a system that runs in the cloud on your local server. You can load it up with the types of applications or modules that suit your requirements. So this might be your cataloging module. Then we add in a thing that we kind of call an app store, although we are very careful to do big air quotes whenever we call it an app store, because although I think the idea and the concept is very much inspired by what you might see on a smartphone, it also is a very different kind of beast when it exists in a hosted environment run by some library or some commercial entity. But we wanted this notion that, you could start with a blank slate and then install just the things you wanted. And if you don't like our cataloging module, you might install somebody else's. So you might have 2 or 3 different ones based on different sets of requirements. So then you add in other types of modules, other functions that you might need, patron management. You might want your circulation. You might want electronic resource management, or resource management more generally. So we have a real ambition in this project to try to take a fresh look at some of these functions, and maybe in particular acquisition, and see what we can do in terms of bringing different modes of acquiring stuff together in a meaningful way. But we don't want to stop at just looking at the sort of traditional and core library functions. We'd like to try to kind of broaden or push open the cubbyhole a little bit of what it means to provide library services. So the project is initially at least focused on somewhat of a research library area or that slice of the universe. So we want to be thinking about what are the types of things that you might add to a system like this to help the library extend its footprint into the academy, into the parent institution. So we start to think about, well, might somebody build a citation management as a part of a library system? Would that be meaningful? Might you have research information systems? Might you have an institutional repository, a lightweight or heavyweight institutional repository built into this, or a front end to a system built into this? Might you have a publishing platform built in to make it easier for a library to assist researchers in publishing things? Might we do something we haven't even thought about yet? In some sense, thinking about this from a platform perspective begins to kind of open a conversation about, what are things that haven't been tried before? We'd like to think of this in a way as an incubator or as kind of a maker space for new types of library services. But in addition to these kind of complete applications or complete functional areas, we also see this quote-unquote app store as being a repository for modules, for plugins, for extension points. Because one of those big frustrations that I had coming in was how hard it was to get a traditional monolithic library system to talk to other things. And so we want to use this as a mechanism by which folks can build plugins or gateways or glue layers, add them to the App Store, enable other people to benefit from them over time. So we want it to be a makerspace or incubator also for integration points. This might be between your acquisition system and a bookseller. This might be between your circulation system and a resource sharing platform or so on. So that's another key area. And then finally, this kind of gives us the basic universe. And so in order to have this also appear to be a nice and a pleasant system, we want to have a common UI layer. So we're prototyping a sort of UI toolkit based on React. We're working on our team with UX experts to try to make sure that what we produce in the end is not just an attractive sort of architecture, but also something that is meaningful and easy to use, something that's designed with the end user, with the librarian in mind as the user. And then the final piece of the puzzle, really, to make this a platform or an ecosystem for these apps, we want to provide a set of kind of system services or storage layers for different types of data. The idea is that if rather than building this as a kind of a conglomeration of business logic wrapped over a relational database or whatever, we provide a set of domain data models and storage layers to manage those. We can hide a lot of the complexity of multi-tenancy. We can provide some shielding between the application code and the database, and we have the means to replace the storage layer if we want to. So if somebody wants to use a triple store for their catalog, they can do that. If somebody comes up with a better type of database engine to use for something or other down the road, they can do that. And we can version the interfaces to these things so that there is control, and so we can approach and collaborate around this platform in a distributed way without getting lost in the weeds. The last bit is thinking about building a platform like this. How do you do that? What sort of approach do we take to make this fun and easy for developers to work on? And that's when we end up, and that's when we come into the language wars. We've got about, as I said, maybe 10 developers in the company, and probably about 10 different opinions about what would be the perfect programming language to use for this platform. So we got into a debate about programming languages that lasted probably about a month or maybe 2 months. At one point in desperation, I went to EBSCO, because EBSCO is providing a lot of funding for this project, and I said, could you mandate something? Tell us that we have to use anything. It could be Java Enterprise, just because then it's your fault and it's not my fault. And they said no, you figure it out. Just hurry it up a little bit, And this reflects the fact that, to their credit, they really don't tell us what to do. They ask us to figure it out together with the community, with the libraries. Just kind of get a move on, please. So what we eventually realized is that there really wasn't any single choice as far as programming languages or development stack that we could mandate that wouldn't annoy some people and that wouldn't be completely obsolete, most likely in 10 years. So we decided to kind of turn it upside down and not mandate a single platform at all. And that's when the microservices idea comes into it, the notion that each of these modules, each of these applications can potentially be developed in a completely different stack. And what ties them together are the interfaces. So we lean on REST-style interfaces that we version, that we manage very carefully, and the implementation of different modules becomes a choice of the developer. So in a sense, the box falls away, and all we're left with are these modules that are collaborating. And some kind of interesting things happen when we approach things this way. One is that we end up with very few big pieces of this. There's really no part of the base platform that's so big that we can't throw it away if it doesn't suit our purposes. And we would imagine that if this platform is successful, that the choices for the UI layer, for the different storage layer options and so on, they will change over time. And what will remain are the interfaces. So the interfaces and our agreements about what constitute good interfaces between components is what's important here. The other piece that's interesting is that you can start to imagine these components actually hosted and provided by different people and by different organizations. And you really start to imagine that if we focus on these interfaces and the domain data models and the boundaries between components that need to collaborate to provide good shared workflows, we can really kind of split the what used to be a very integrated and monolithic function up to be something that just kind of comes from all over the place. And to my mind, I think that reflects really the idea of what putting this kind of function into the cloud reflects. It reflects what we see, I think, with other types of services that we buy now from web-based providers. And I think is a really interesting perspective. In some ways, although we don't call this an integrated library system, we call it a library platform, it could also be a kind of a transition phase away from having that function be integrated at all. The universe that we can imagine is one you just kind of buy the different functions that you need and combine them when you need to. So that's a key. The next key is the notion of the community. We are hoping that by having a platform that can be a lot of different things to different people in libraries, in research libraries, in other kinds of libraries, and other kinds of institutions, that we can attract a critical mass, not just of developers, but institutions and companies to actually make this sustainable, to create a larger conversation about library services, about workflows, about how things work together, that I believe that the space needs. Because libraries are pushed, they are threatened by budget cuts, they are threatened by different models of accessing content and information. I think there's a need for innovation, and in my own sort of personal experience, an open source project is something that can bring that kind of conversation. So one of the big roles of OLE is to help stimulate, is to help drive that conversation, or to help build that community. You don't have to be a member of OLE to join and to play with this. All you have to do is show up and be interested, be part of the conversation, maybe contribute code, maybe not. So that's what we're hoping to accomplish. So as I mentioned, there is not really a website as such. There's a place where you can go and put in your email address if you'd like to be informed. Once we put a website up, you're welcome to contact me. I want to give a shout out also to Michael Winkler, the managing director of OLE, because he's somebody who can answer a lot of questions about this. Are you actually here, Mike? Wave your hands and make yourself known. Somewhere hiding behind the lights. And Christopher Spalding from EBSCO. The two of them are sort of my partners in crime in terms of this, and feel free to look up any of us here and ask questions, send emails and so on. So thank you very much.
Okay, our final talk for the first part of the afternoon will be given by Camille Salas, John Nelson, and Will Boyd. And it's called Transcending Traditional Systems and Labels, an API-First Archives Approach at NPR. Is it on the desktop? Great.
So we just need to put it over here?
No, you actually just go to presentation.
Oh, it's just the same.
Presenter. Yeah.
Yeah.
Okay. They're going to put it. Okay. Just press it there. Thank you.
Good afternoon. My name is Camille Salas, and I am a product owner with NPR's Research, Archives, and Data Strategy team. also known as the RAD team. I am joined today by Will Boyd, the RAD team developer, and John Nelson, who is a developer and was formerly with NPR's digital media team. We have a lot of ground to cover today, so please bear with me if this moves quickly, and you're more than welcome to visit with us after the presentation in case you have any questions. So our presentation today is about our current project to refactor NPR's internal digital archive of broadcast audio and transcripts. And before we delve into the technical overview of that project, I'd like to share a little bit of historical context about how this project came to be. So NPR's archive started in the 1970s when we received a grant from the Corporation for Public Broadcasting that allowed us to hire our first librarian and establish our archive. If you would not mind, I'd like to read a few sentences from the letter that kind of explains what our archive is like. And it is at the bottom of the screen, so I know that's been an issue throughout this conference. Let's see here. It is our intention to make this library an active depository which will make programs and program materials available for production and broadcast purposes. It is also intended to be an archive in the academic sense for historical and scholarly purposes, but this will be an evolutionary development. And the phrase evolutionary development continues to remain true today, and I think our presentation will demonstrate that. So metadata has been an integral part of the archive since its beginning for many, many reasons, not only per the stipulation of the grant, but our metadata is used to create a quarterly report that is required for federal licensure. So if it wasn't for the librarians entering metadata about our on-air content, there would be no report, and without the report, there would be no NPR on-air content. Not only is our metadata used for federal licensing, but it's also used by our organizational partners. It's used to research the diversity of our on-air sources. It's used for budgeting purposes, and it's also used for grant reporting as well. So as a result of librarians cataloging shows like All Things Considered and Morning Edition, we've been able to find stories from our very rich 40 years of history through our current digital archive. However, a lot has changed since the 1970s in terms of technology, and in fact, we have adopted a Scrum and Agile framework towards the way we conduct our cataloging, the way we do our research, and as product owners as well. So our current project came to be after two previous iterations of the internal archive. Around 2000, we had our first CMS, and it was akin to an Access database. It was very time-consuming. Reporting was very difficult and challenging. And in 2011, we moved towards our current archival database, which is called Artemis. And Artemis ingests XML transcripts that not only pre-populates it, but also delivers transcripts to npr.org. And if you've seen any of the transcripts on npr.org, that goes through Artemis first. So even though Artemis has met many of our system requirements, it's pretty inflexible. And for our growing archival and business needs, such as an emphasis on new NPR content, including podcast and video, and we want to think about future content that's coming our way, something that we like to call braincast. We just don't know what's coming down the pike yet, but it's going to happen, and we're certain it's going to happen as media is disrupted all the time. So our team came to the realization with our digital media partners that our current system was impeding us from moving forward. And we also wanted to think about what else was impeding us, and we had made this name change or rebranded ourselves. We no longer call ourselves the library. We call ourselves Research, Archives, and Data Strategy, and we wanted a system to also reflect that name. So our department learned a lot from previous implementations, and we understood that metadata reporting is a growing priority. Our deadline-driven environment means speed and flexibility is important to our stakeholders, especially our reporters. And we also knew that we had the skill and framework in place and in-house talent to create our own solution. So in short, NPR has very unique archival search and business needs. And we wanted something that we could show the rest of NPR, that we could adapt just as quickly as the rest of the organization around us has. So these are some of the requirements that we had kept in mind that ring true for our previous systems as well. But you'll notice at the top, flexibility is what was our number one priority. And I'm going to turn it over to John Nelson, who's the primary architect of the system, and will explain how we went about implementing it.
All right, thank you, Camille. I just first I want to switch gears slightly and take a second to give a quick backstory about the first time that I met Camille. She comes over to my desk and says, "Hey, are you John? Have you worked with Artemis before? And I said, yeah, I mean, I've spent some time with Artemis, working with previous iterations and doing stuff like that. So I said, she asked me, she says, can you come with me to this meeting I'm holding about Artemis and the things that I'm kind of trying to, give everybody an overview about Artemis and what it does. And I said, great. So, I go to this meeting with her that day, and I'm sitting in there, and she gets up and she introduces me as the expert on Artemis and says, now I'd like to have John come up here and explain the infrastructure and Artemis and how it came to be. And so to my surprise, I kind of get up there and, I wasn't mad or anything, but, I get up there and I give an overview of kind of the infrastructure and how, what its current state is and that sort of thing. So, and I use that time to actually pitch the new idea that I had kind of mulling around in my head about this API first application process that we were, that could basically revolutionize Artemis and its infrastructure. So that's when I knew that she was going to be a great product owner. She really went out and found the person that was the best at what they did and had the knowledge of the product, and was perfect for that. So that's kind of where this API first application approach came from and where it really started out. And so from there, we kind of started in 2015 with this idea that we needed to build something kind of from the ground up to kind of revolutionize the idea of our content and how it got distributed and how the build process was going. So we started with our data model because that was the most important part of our system and how we needed to get it to move forward. And the reason was because we had a lot of problems trying to get our new content into the system and a lot of custom development and a lot of things just to get new programs or things into our API. So that was one of the key parts that we started on with everything. So from there, we also went to we started working with. So from there, we kind of like set on this analogy of a trapper keeper. So with content like separated into the dividers and the folders and pages and as that sort of all kind of fit into our structure. And then we moved to relational data. We moved away from relational databases and embraced the NoSQL world, getting away from all of this very structured data into something that was a lot more flexible that we could sort of handle this new and improved data model as we move forward. We used hypermedia as our object, as our data structure. We had a lot of familiarity with this in past projects that we worked at with NPR. And so we're kind of working on this model of code reuse and sort of this fast prototyping of application development. We also separated our UI and the API so that we could make UI changes without any real data model changes and that sort of thing. So it made it, this provided for a much more rapid development environment than we had previously experienced. And so with that, I will turn it over to Will Boyd, and he will talk a little bit about our UI and development process.
All right. Thanks, John. So as John and Camille mentioned, I'm Will Boyd. I am the full stack developer for the NPR Rad team. And I came onto this project, and my first goal was to start the front end. Before working on Artemis and being hired at NPR, most of my front end development experience was with Backbone and jQuery. So I was a little intimidated by Angular at first. I thought the docs were really confusing, especially the examples, and the lingo was really fancy. And in fact, if you're just learning Angular, I probably wouldn't look at those examples first. But after a few weeks of working with it and reading a lot of best practices, I've realized that Angular is actually way easier than Backbone. It does so much more for you, and it's really fast to put things together, especially forms and views. So onto our setup. We set up the front-end development stack with Yeoman and Jenkins. I think that's how you pronounce it. We use Git, and whenever we commit our code to the master branch, the code is pulled, installed, tested, and served automatically. It only takes a couple minutes, and this has provided us a ton of value. It's probably saved us dozens of hours of development time because there's no overhead. Setup also means that I can install a local copy of the app from any machine that has Node in less than 5 minutes and be developing anywhere. So since we don't have a ton of time to spend on the front end, I'm just going to cover a couple of my favorite features. The first is every application state is stored in the URL. It would have been a lot easier to not do this and just have the application state kind of relevant to your browser session. And you might have noticed this with other sites. This happens when you're clicking around on a website. You'll save the URL, and you'll notice when you go back to that URL that you're not actually on the same page that you remember being at. You might even be at the home page, and that's usually because they don't store the application state in the URL. So we took the extra time and code to make the URL reflect all of the application states that there are, and that's been incredibly valuable for us. And here are a couple examples of that. So on this slide, you can see an example of a search URL. It's the hideous URL at the top. It doesn't even really fit on the screen, but that's okay because I can share this URL with a colleague, and they can see how I built the search with the basic search term, the date, and also any of the advanced settings that I set up because that's all in the URL. And also when they come to this page, it'll automatically search for them. Here's another example of a story URL. This is an archived story, and it's coming from the same search that I just performed. So if I were to scroll down, I could see more of the story, but you can see at the top that we still have the search stored in there, and that's coming from the URL again. So they can go in and they can see the story, or they can rerun the search, change the parameters to fit their needs. And an unexpected side effect to this that I wasn't really thinking about when we first started it is that this makes dealing with the browser history much easier. And if you've ever built any apps with JavaScript frameworks, you know that is kind of a pain. So the next feature. NPR is always adding new content. This means that we have to be able to quickly support that content with our archiving. Camille doesn't want to have to use developer hours whenever we add a new podcast, for example. So what we did is we created a CMS for the cataloger, and it's powerful. This here is the editing view for a schema. The schema defines a content type, and it shows the attributes. And going back to that trapper keeper diagram, these content types match the diagram. Camille can add, remove, and change the order of the attributes, but she can also organize them into groups, which she also has full control over. And that makes it easier for users to understand. It also means that we're flexible into the future. If we want to change the way an attribute works, or maybe it's becoming a legacy attribute, we can move it towards the bottom or even hide it from the user. She can also add content simply by clicking new, and then I'm going to show an example of a show here. So here, we're adding a new show, maybe because we're creating a new podcast. All she has to do is create the parent document, and then we're ready. What if we want to start archiving npr.org's metadata? You know, we could create extra fields on stories, or we could create a new content type that's specific for online-only content. We even started using the API to create utility content types, such as managed lists, like audio format, cataloger names, and role codes. Those are used in conjunction with other content types to provide a rich CMS. And the point is, the type doesn't really matter. The API that John developed is extremely flexible, and the CMS just lets us take advantage of it. So we've got this front end, and we've got this API that's kind of agnostic. But what about the stuff that needs to run on the server? Some of that stuff can be put into the browser through the front end, and most of it isn't really suitable for the API because, like I said, it's agnostic. This is logic that needs to be specific to Artemis and should be on a server. So we thought, well, we have to do authentication with private keys, and we also need to log in with our company username and password. That can't be on the front end because our Active Directory requires permission to authenticate, and we can't add everybody's IP address to that. So what we ended up doing is creating a proxy layer. This proxy layer is really just an API in front of the API, but it's specific for our logic. It's built with Node.js and Express, which happens to be what the agnostic API is built out of, but it takes care of the stuff that I was talking about in the last slide, like API token authentication and company login. But it's also grown a lot because we keep finding more uses for it. It's been really useful. You know, there are a bunch of internal APIs at NPR. So we can put that communication on the proxy layer, and then we can cache the results if we need to, and we can keep private things that are meant to be private and not put them in the front end. So here's an example of pulling in information from npr.org using our internal API at NPR. We can also query and use our taxonomy. Our taxonomy is stored in a system called Mondeca, which is actually really cool. and it has an API, but it was never meant for real-time querying. So, querying for the taxonomy is really slow. So what we do is we cache it on the proxy server, and then when a cataloger is going in and archiving a story, they're able to use the taxonomy explorer to apply terms. We can also use the proxy to run bulk updates, get and set user preferences, exporting search results. There could be thousands of search results, and you don't want to run that many queries on your browser. And we also browse the mounted file system to view our audio files. So, migration hardship. Not everything is awesome. It turns out. It's been a real struggle for us. When I say migration, I mean moving all the content from the MySQL database into the API for Artemis 2, which is built out of Elastic and DynamoDB. And it's mostly been a struggle for us because of volume. We have over 1 million records that we need to migrate. And because of the nature of the technology behind the API, that means we need to make at least 1 million HTTP put requests to actually get the data into the API. So just to give you an idea of the time that takes, a SQL dump of a year of data in MySQL takes about a minute. Inserting that data into the API takes about an hour. So we have over 40 years of data. So that means that if we miss a field or make a mistake and we need to remigrate everything, it takes 40 hours at the least if everything goes well. So that usually ends up consuming a full sprint for us, which is 2 weeks. So there will be mistakes. HTTP calls are going to get dropped. There's always going to be duplicates, so you have to think about that, and the list really goes on. So my advice is if you're doing a similar migration is don't underestimate the effort that it requires, because we definitely did. That's it for me.
But because we work in an agile environment, we can adapt. Okay, so Will gave an overview of some of the lessons he learned. I wanted to provide a little bit about the product owner's perspective on things. API first has in fact been awesome for us. It meant our front-end options were limitless. We worked with our internal UX team to come up with an interface that looked like and felt like NPR, as you kind of saw in the slides that Will brought up. And as Will mentioned, deploying the front end was really easy. So whenever he gets going, I can test within minutes of him making an update, which is awesome because flexibility is definitely what we desire in the role that we have at NPR. Another thing I would say is documentation is key. And in addition to the trapper-keeper model, we had a lot of decisions that we made at the outset of this project, and we go back to them time and time again, and we reevaluate and we update that documentation. It's been invaluable to us. The other thing that happened during this project was I had to take a brief hiatus. Our taxonomist, our awesome taxonomist, Sarah Knight, who could not join us today, but she filled in for me and kept the momentum going on this project. Additionally, John mentioned he's no longer with us, but Will was able to pick up the torch and keep going. So planning on those backup resources is also key. The other thing that is critical on a project like this is not all your team members will be familiar with the jargon that you are using. So managing expectations is pretty critical to get that stakeholder buy-in. And it's hard to demo an API. Our colleagues are more concerned with the interface as opposed to the functionality of things. So you really have to kind of work on translating what is happening into a language that they understand. So the other thing that happened was we mentioned Scrum a lot, but it's been really invaluable to the way we work. We started out with a Scrum Master and a developer and a product owner and a backup product owner, and then our team kept getting whittled down, and we lost our Scrum Master. But even though losing some of those key roles, and we didn't have all the ceremonies that the Scrum framework has, we still kept moving on, and adapting is definitely key. So next steps, we are anticipating a spring-summer 2016 launch if all goes well, and it will. We are looking to do auto-tagging on our broadcast transcripts and hopefully future additional NPR content. And we are looking at ingesting additional NPR content, which is why we went this route. And we want to free our metadata. We want to put it out there into the public, details to come on that. And finally, we want to support our NPR One app colleagues. If you haven't downloaded the app, please do. You can not only hear our stories that we archive on the air, but you can also hear them in the app. And we encourage you to follow our adventure at NPR_rad. Thank you all so much for your time today.
Okay, thank you, NPR folks. Okay, just a couple announcements before we go to our break and our breakout sessions for today. First off, I just want to make sure that everyone knows during snack, the baked goods, we were informed they were made in a facility that has allergens, so if you're allergic to nuts, I don't think any of those would probably be a good idea for you. Sorry about that. Number two, Lightning Talk signups for tomorrow morning are going to be, you'll be able to sign up for Lightning Talks over by the registration desk. And, excuse me? One spot left. Oh, one slot left. Okay. Go for it. Okay, and finally, I'll just announce where the breakout sessions are going to be meeting. I think we had one addition, actually, and so I'll list them. Dave, is the addition on this page or no? It is? Okay, great. So metadata assessment in the Bromley room, Mashcat in the Claypool room, web library IT accessibility in the Cook room, Vivo linked data, Git for data in the Flower room. And just be sure to write these down because they won't be posted to the website in time, or if at all. The breakout sessions will, the locations won't. Archive space, APIs, and integrations in the Frampton room. Community diversity in the William Penn boardroom. Building a coalition of libraries running tour exit nodes in the ballroom far left. That's your left, so all the way over there. Viewfind, ballroom far right. Your right, all the way over there. DevOps for lib, ballroom left middle, so over here. And rethinking the Summa data collection client, which is the new one, in the ballroom right middle, kind of in this vicinity. Okay, thanks everyone. Enjoy your break. get going. A lot to fit in this afternoon. Just want to make a couple announcements real quick. We're going to do 3 giveaways, and then we're going to start the presentations. Also, if anybody is interested tonight in the Hamilton room, one of the rooms where we ate lunch and breakfast, we're going to be doing a play and share. It's lots of games, board games. There's going to be an open jam, acoustic jam. Here we go. Who's it going to be? Thank you for the music. Andrew Gerhardt. Are you here, Andrew? Andrew is not here. All right, we're gonna try this again. That's why you gotta get back in. Okay, second try for the first giveaway. Is Ann here? Yeah, all right. Oops. All right. Second giveaway. It is. It was at least 3 years ago when I grabbed it for the Chicago conference, and I just found it as I was migrating files. Uh-oh. So we can't see this, but I can see it. Benjamin Murphy. Is Benjamin Murphy here? Yeah? Yeah. There we go. All right, I wasn't lying. Is Benjamin here? Yes? No? Okay. Sorry, Ben. Second round. Take 2. Sarah Sheely, happy birthday. Sarah, I know you're out there. I just talked to you. There she is, yes. All right, round 3. Final round before our talks start. I know I'm wearing my lucky socks. They have floppy disks on them. Laura Smart. Is Laura here? Uh-oh. She's not. Okay, we're going to have to go with one more round. And then if this doesn't, we'll try one more time. If the person's not here, we'll just carry on so we can get going. All right. Round 3, take 2. Bonnie Gordon. Is Bonnie here? Yeah, all right. Congratulations, Bonnie. I will, do we have time for sponsor announcements? No.
Here, I also posted it in the Slack. And so I'm going to ask some rhetorical questions and then show an example demo application. So why in the world would anyone want to build desktop applications these days? Like, so much cool stuff has now moved onto the web and onto websites. Why would you want to? Why would you want to do it? So, okay, a little survey. Who here has some role in creating web applications? Any role? Project manager, developer? Okay, lots of hands. Who here has some role in creating desktop applications? Some, but many kind of grouped right here. Many fewer. Okay, so the web has one, except on mobile. So, yay! Now we have too many tabs. And so like on Chrome, like you see the favicon, and on Firefox, you got to scroll back and forth in order to see all your tabs. Like, there are whole classes of extensions for browsers just to deal with how many tabs you have. And then, like, I use bookmarks mainly so I don't feel guilty about looking at that tab anymore. And then I have good intentions, but never go back to it. That's what Pinboard is for me. And then, like, I'll sometimes just claim tab bankruptcy and hope that nothing important got lost in there. And so, you know, so too many tabs, just open another window, right? And then you've got, like, 10 Firefox windows, and it's like, which Firefox window? And some of them probably have the same content that's in them, so how do you find what you're working on? Okay, so why desktop applications? So you stand out. So you can focus on something. It's really hard to focus when this tab is sitting there with your Gmail unread count. So you want to focus. So why not desktop applications? Anytime I've tried to develop a desktop application, like trying to deal with GUI toolkits, and they're just ugly and difficult to work with, at least for me. I don't know. Felt people in this section? Yes? Okay. I'm not off base there. And so, but the thing is, all you people who work on web applications already know how to create a user interface with web technologies, HTML, CSS, JavaScript. You know that stuff. Okay, so there's a couple different platforms that I know about for developing desktop applications with web technologies. I'm going to be talking about Electron. And I want to give some flavor for the kinds of things that you might build with Electron to give you some ideas for how we might be able to use technologies like this in libraries. So there's lots of companies that are using Electron right now, lots of open source projects as well. As I was creating this slide alone, like every other day I would have to go back because they were adding new little icons of different companies to their homepage. And so who's using the Slack desktop application? That's written in Electron. Discord, used for PC gamer communication. That's written in Electron. Lots of collaborative tools are written in Electron. Avocode helps designers communicate. Flow does team task management. So why would you develop a chat or collaborative tool using Electron? Again, that kind of attention. Rather than having it in the browser, you can focus. Notifications, then there are new web technologies like WebRTC and WebSockets, which make developing this kind of applications much easier. And then we get to code editors. Atom Editor from GitHub, Visual Studio Code from Microsoft, Nuclide from Facebook. So like big companies are using this technology. And then editors. The new WordPress desktop application is an Electron application. YHat Rodeo is an IDE for data science. And then lots of Markdown editors, of course. So why code and text editors? Because it's hackable. It's all just markup. You can create lots of plugins and develop a community around your tool. And lots of developer tools around Git, SQL editors, HTML5 game development. And then the one I thought was really interesting was hardware configuration. So Particle is a board for doing Internet of Things development. SteelSeries Engine is for configuring gamers, keyboards, and mice. And then Jibo, which is a social robot. Little tangent. I wasn't convinced about a social robot, and then I watched the videos with one of my daughters, and she like fell in love. And I was like, maybe there is something to social robots. Anyway, so why hardware configuration? Because you can build cross-platform applications that auto-update, that report on crashes. You're able to run another binary as well. And then there's all sorts of crazy other applications that people are building, like an ambient sound mixer and a GIF maker. Okay, so what exactly is Electron? It's just Chromium plus Node.js. I'll explain a little bit more what that means. So because it's Chromium, you have access to all of the different web APIs that you already know, and you have access to everything that Node provides you as well. So my entrance into Electron was through Atom, the code editor. Electron was formerly known as Atom Shell, and I thought it was really cool because I could go in and actually see how it's working by opening up the developer tools inspector and doing things like changing the color of something and actually see how it works. And then what really hooked me was this plugin called I'm Done Atom, which creates like a Kanban board right in your code where you're already working. Really cool package. Okay, so I'm going to show a demo application and some of the features that I think make Electron really interesting. Who uses JPEG 2000 images? Okay, some of you. Who has memorized all of their JPEG 2000 conversion command line options? Anyone? No hands? Okay, I haven't either, because these are ours, thanks John Stroop. I don't know what most of this does to even remember what it would do, but it works. So I developed this little demo application to do JPEG 2000 conversion. So think like Handbrake is to FFmpeg as JPEG 2000 converter is to OpenJPEG and Kakadu. So you can open up a window. This is what it looks like. And the first thing that you'll notice is it has desktop integration. So you can Control Tab to be able to get to it. And then here's what it does. You drop some files in, you click a button, and it goes through some steps to create JPEG 2000s. Pretty simple. It also ties together a bunch of other command line tools. You've got to make sure that the TIFF that you're using to feed into Kakadu or OpenJPEG is RGBA, things like that, cleans up temporary files. You could do this totally as like a command line script, no problem, but I just want to play around with some of what Electron can do. And this all starts with a script tag that's in a normal HTML page. And then here's some CoffeeScript where I require jQuery, and on document ready, I hide some stuff from the view, and then do the image conversion, send a notification that all the images are done converting. And then this is the code that actually converts the image. Require child process and FS for file system, and then actually execute the command. But wait, okay. This code is running in a browser from a script tag, and it can do things like this. With child process, you can shell out to be able to list the contents of a directory, but you could also, with the file system module, like delete files. Again, this is code basically running in a browser. And this was the moment when I was like, my head was like mind-blowing. Like, whoa, I can, yeah. So like, Electron apps allow you to connect directly to a database, manipulate any files in the file system, kick off processes, send desktop notifications, use any of the native APIs like the microphone, video camera, record media, all without asking. Okay, so a little bit about opening an image viewer in a new window to see the results that we've converted. This is called inter-process communication. It's really simple. You get this IPC renderer, and then when you click a button, you just send a message, just like you would in a lot of other JavaScript. And then the main process. So Electron has a main process, and then it has render processes. And you can open up as many windows as you like, and you communicate through the main process. And so you just listen for the open JP2 message, and then you do something with it. And so you click a link here. It opens up an OpenSeaDragon viewer, and you can see the image that we just converted. And again, you have the full power of Node.js there. So you can do something like embed a whole Node web application, in this case Express, into your Electron application. So you can use all of the same sorts of web endpoints that you would in a regular web application. So here we can get the IIIF info.json. We can extract the requested image from the JP2 and return it back. And so this led to a little bit of yak shaving while I was doing this presentation preparation. So I ended up creating node modules for using the IIIF, for creating a IIIF image server. And then I used those in the JPEG 2000 converter, and then ended up also building a full IIIF image server as well. So what are some issues with Electron? So one of the selling points is that it's cross-platform. I can develop this thing once, and I'm going to be able to deploy it on Mac, Windows, Linux. But the packaging, it's pretty automated. That's pretty easy. But then when you're trying to actually build installers, I had hoped by the time I came here for this presentation that I'd be able to give you a download link of some application I had developed, and you would be able to install it right now if the Wi-Fi was working and actually use it. But I couldn't get any of the installers other than creating a deb to actually work. And then there are subtle differences between the different operating systems and how you're going to actually integrate with the operating system, integrate with the dock, the taskbar, notifications. And then there's the issue of if you're using any native modules, how those get rebuilt or distributed. And the simplest thing is just if you want more resources on Electron, just go to Awesome Electron. It's got the best list of resources there, so I'm not going to try to reproduce the resources there. And that's it. Thank you. I could just go back to that slide and watch it for 2 minutes if you like. Question over here? Okay. Runner is running.
So I'm pretty happy with the Slack client, except for the amount of memory it eats up. Is this a general characteristic of Electron apps?
Yeah, I don't know. It may very well be. Yeah, could be a fair criticism. Anyone else? to do printing, no, I haven't done any code to do printing. But yeah, that'd be interesting. I mean, you basically have Chromium, so it'd probably work the same way as Chromium. Create a PDF, print from that. That's usually how I end up doing it. Okay, thank you.
Thank you, Jason. Next up, we have Beyond the Bento Box, using linked data and smart algorithms to integrate repository data in context, with Jordan Fields and Mark Noble. Let me just get to the desktop here. Right here.
Hi, everyone. My name is Jordan Fields, and I'm the program manager for the Digital Archive at Marmot Library Network.
And I'm Mark Noble. I'm the R&D manager and programmer at one of two.
Yeah. And we're going to talk to you a little bit today about what we are doing with discovery in libraries. So I know most of you know the history of discovery in libraries, but I do want to go through just a little bit. So in the beginning, when we first started discovering our online resources, we were a lot like hunters and gatherers. I've heard it described as berry picking. So we had all of these disparate systems, and they required skills. You had to know where they were. You had to read the manuals on how to search them. And it was complicated, and you needed to be essentially an expert in a bunch of different things. And then we thought, well, hey, we're going to combine our indexes, and this is going to save us a whole lot of time. And you're all, again, familiar with this concept. Instead of going out and gathering the food and having to cut it up and prepare it, we now have salads, which are great. We love these. It's a lot less work for us. But along with that came a few problems. I don't know how many people at the buffet today got to the waffle fries and wished that they had more room on their plate. Or got to the end and, yeah, I see you. I got to the end and said, there's a giant thing of liquid cheese up here, and it just kind of ended up everywhere. I got some in my soup, ended up places the liquid cheese shouldn't have been in my food. And that's kind of what happened once we started combining all of our indexes. It got really, really, really messy sometimes, and our users could not find what they needed. So then what many, many academic libraries use now is the bento box. And this is perfect. It's exactly the right balance. You can see where you are. You know what you're eating. There's no unfortunate overlap between resources and you're not actually missing anything, like I couldn't get the waffle fries, or at least enough of them on my plate to make me happy. But you can sometimes get stuck in these boxes where users maybe don't even know exactly what it is that they're looking at, or they get stuck in there. So they're looking for articles, and really they need to be in your archive, but they didn't choose the archive box in the beginning. Or their search has evolved. So they thought they were doing one thing, and then they kind of followed down this research, narrowing their topic. But because they're only looking at articles, that's obviously biasing the material that they're getting. So we have, this is all academic libraries. Forget public libraries. Public libraries are still stuck with hunters and gatherers. They have completely different problems, because for them, the bento box doesn't meet their needs, because articles are not given the same weight as their regular resources in the catalog, because public library users tend to want the resources that are in the catalog first. But the problem is that they do have archives, but again, you have to know where they are and know how to use them. And they do have articles that libraries spend thousands, tens of thousands, sometimes hundreds of thousands of dollars in public libraries and are drastically underutilized. So for what we're doing, I tried really, really hard to come up with a food analogy. Far too long, much time was spent thinking of this, and I just couldn't. So I decided on choose your own adventure, because this is really what we're doing. You start with a search, you pull your book off the shelf, but then at any point in the process, you're given relevant options, relevant to what you're searching right now, relevant to what you're seeing on the screen, or what you're seeing in your search. you're just seeing all the relevant resources from the other places. So you have the catalog. In our case, we're using EBSCO Discovery Service EDS to combine some of our articles, and then also our digital archive. So before we get into how we're doing that, I wanted to tell you a little bit about us. So we're from the Marmot Library Network. We are a nonprofit library technology consortium. We have 27 consortium members, all in Colorado. You can see here there's a heavy public library bias. We do also serve, though, academic libraries and 5 school libraries. So if you can imagine trying to design one discovery interface that meets the needs of all of these people, it's really hard. And then we also have some people that, in addition to our regular members, we provide other services to, but we have people that just see us for discovery, including, again, mostly public libraries, and also one crazy place that combines one discovery for both their public and their school libraries that are actually on 2 different ILSs. So if you're curious about how that works, James is in the front row and you can ask him. It's crazy. So our discovery layer is based, it was originally ViewFind, but we made some changes to it, the types of changes you'll see today. And it just got too confusing to keep calling it ViewFind, so we renamed it Pika. We've been too busy doing development to come up with a logo, so I put a cute picture of a pika in there so you know what I'm talking about. Get it? Marmot, pika? Small mountain rodent. Everything that we combine, everything below are things that, that you can discover in our discovery layer, not in all of the implementations, but we work with a number of different ILSs. We were some of the first to implement some of the digital resources, and then our newest things we're talking about today are Digital Archive, Islandora, as well as EDS, EBSCO Discovery Service. So the goal for what we're showing you was that at every step in the research process, the user is presented with relevant suggestions from across all of the library resources. We're not doing everything right now, but we do hope to someday include some of the other bento box places that you'll see, places like the library website for things like events. So when you're looking at looking up an author, you can see their events. A few caveats. This is code4lib, so it's still in alpha. We're still working on it, although we do have screenshots to share with you. Lots of things like placeholder icons. We've done some usability, some CSS, but it's not perfect. We have usability studies scheduled over the next few months, actually. And a lot of what things are labeled, and then also, of course, algorithm refinements. Every time we add a collection, we discover something new. So I'm going to hand it over to Mark to give us a quick tour of what we've done so far.
All right, thanks, Jordan. So yeah, I just want to go through a little bit of what we have so far, what we're presenting the user with, and then we can talk a little bit more about how it works. So we're going to start, so we put these slides together thinking about a student doing a presentation or preparing a paper about Camp Hale, which is it was a Army camp in Colorado, up in the mountains. They were training, the 10th Mountain Division was training there to go to Europe and learn how to fight on skis. So there's lots of great information there. We've got some articles, we've got some books, we've got images, but we haven't really been able to find those. So we want to really get all of those resources in front of our target audience. So in this case, the student has started with a search of the catalog. So we're seeing regular catalog results here. We've got a couple of books. These are great books, but if the user scrolls down a little bit, now we've presented some other resources. So we're starting to show article information, academic journals, the magazines. If they scroll on that, we can see some other things. So we've got all results from EBSCO, and then we start diving into some of the archive content. So we've got projects related to it, we've got images related to it, all kinds of great resources that the student might not otherwise know to use. And we carry through that. So when you start clicking on this and go to start looking at, let's look at the EBSCO journals or something like that. So we're getting results now from EBSCO. We're looking at the EBSCO APIs. We're presented with all the different information from EBSCO, as well as now links back to catalog resources, as well as the digital archive information as well. So we wanted to make sure that everybody is getting the right information at the right time, but we really also wanted to make sure that they were getting the best experience for where they were. So if you noticed on the last slide, we had facets related to the catalog. We've got different facets now that are based off the configuration of EDS. And then going into it, we get other results from the digital archive. So those, again, have different facets. So we want to make sure that the students are getting the best results possible for the section that they're in. And then we follow that up with when we're looking at an item-specific page. So in this case, we're looking at a book that is specific to Camp Hale. So we now see in the sidebar, we've got information about that specific location. So we've got lots of good details about the place itself that we want to present to the patron. We've also got similar titles from the catalog, and then additional resources from the archive. If we scroll down some more, we have additional resources from the archive. And then looking down even farther, it's a little hard to see. It's cut off at the bottom. It's probably behind a lot of people's heads. We've got similar titles from novelists. So we're drawing all of that enrichment content to get people more resources. So we're hoping for that serendipitous discovery that, hey, I didn't know I was looking for an image. How do I? But now it's there and I can use it. So as we dive into looking at resources from the archive, so this is a picture of a ski trooper jumping down the mountains with the gun on his back. So something that would be very useful for a student in their report, potentially. From there, we can also see more of their similar type of information from the archive. We've got our collection where you could find more titles related to this, more images, more articles, more oral histories. The third item down there is the United States Army 10th Mountain Division, so we can provide additional information about specific organizations. And then the same related titles and EBSCO titles. Similarly, when we're looking at an EBSCO page, we can get back to the archive. So we really want to make sure that it's a consistent user experience for the user no matter where they are. We don't want to get in their way and present too much information overload. We want to make sure that they're getting the information they need without it being overly obtrusive. So let's talk a little bit about how it works. So in that Explore More bar, we're pulling information from a couple of different sources. So basic, just EBSCO EDS API searches. I've got keyword search and novelist there. It's not novelist at all. It's, that's our archive. So down below, it's EDS searches. The first one is we're looking at the archive and pulling related entities out of it there. So this is all entities related to their search terms. So we're doing some keyword searching, subject searching of those. Individual articles are coming out of Islandora as well. So we've tuned the Islandora Solar instance a little bit to try to get us the right matches based off the keywords that students are entering. And then we're also looking at the relationships as well. So we want to say, in Camp Hale, if I search for Camp Hale, I'm going to find a bunch of articles that are tagged with that, but the people may not necessarily be tagged with Camp Hale. So we're looking at the metadata for the objects and then the relationships. So we've got linked data between the images and the people themselves. So we can kind of show those relationships. So for an individual entity page, so entities, people, places, events, we're looking at some linked data that we can pull in. So we're pulling address information from who's on first. We can pull it from geonames, standard basic stuff. We can get linked data from Wikipedia. We're using some linked data to tie in and say this article is specifically related to Camp Hale. So our catalogers can put the correct information in there. We're looking to add some more information on the linked images, oral histories, all the articles that are related specifically. That information will go in here. That's going to go on kind of the main page where we want to say this is all content that is specifically about this entity rather than just related content or similar content. So another image here. This is the Camp Hale billboard where they have Camp Hale punching out Hitler there with Hirohito in the background. So again, we've got our linked data looking at the collection that we're part of. The books and more is the important part here. So what we're doing is we're pulling out the subjects for the image and trying to tie those back into data related to which titles from the catalog might be interesting to the student. So if they find this image and they want to find out more about it, we want to direct them to the correct titles in both EBSCO and the catalog so that they can actually get some things they can cite. So some of the linked data sources that we're pulling right now, who's on first, geonames, we're doing direct links within the catalog itself. We've got a genealogy database that our catalogers are linking to for individual people. We're linking within the archive itself, linking out to Wikipedia, Find a Grave, and it seems like every week people are coming up with a brand new source that they'd like us to integrate. So I was talking a little bit on the last slide about how we're doing the subject-based searching. So a lot of the complexity we're hitting, like we've talked a lot about this week or the past couple of days, is the subject terms and how they don't necessarily relate. So when we're in the top record is from a cataloged record. We've got lots of great LC subjects. But that's not how they're described on the bottom left there. We've got the subjects as they're in the cataloged records for the images. And then on the right, we've got a couple of different examples of the subjects in EBSCO. So it's really difficult for us to pull data directly over and say, oh, well, if you want to find images in the article database, you need to search for United States Army Mountain 10th history, which is the LC subject. That wouldn't get you good results within the archive or vice versa. We had some fun stuff where we were doing some searching based off of information in the archive, and very reasonably, they had been tagged with things like pilot and planes and hat, and which makes perfect sense for an archive. That's exactly how you want to describe things. But when we try to start relating that to the catalog, we got, here's how to fold a paper airplane. And that wasn't quite what we were looking for. So we're needing to do some things where we're starting to filter out some of the subjects and say, here's things from the archive that we don't necessarily want to promote when we start looking at catalog results and article results. We think we're probably also going to do some cross-mapping of some of that. So there's probably some linked data there that says either buildings is relating to this other one subject term, or potentially when we start seeing, hey, a combination of buildings and military, we can use that to say, here's the correct LC subject heading to use. So we've got a lot of refinement of those algorithms to do to kind of figure out what the best way to do it is. So that's our biggest challenge. Some of our other challenges are we just have a lot of new tools to learn. So we've had this archive now for a grand total of 6 months. So we're working hard to get it all integrated, but we've got a lot to learn in terms of Islandora, some of the linked data and that kind of thing, learning all of our best practices, other new technologies. And then we all have other stuff that people want us to keep doing as well. So it's always a challenge to get everything fit in. So some of the things we've learned so far about when to use linked data. Right now, we're primarily using linked data when we have a good known relationship. So this is the same as this is related to that. That's our primary use of exclusive linked data, at least within the archive. We're using a lot of those algorithms to improve results. So we're looking at doing subject searching. What can we do to filter things automatically? What can we do to improve our results? We'll use a combination. So as we start processing some more of those subject terms and say, here's 2 things that we think are going to give good results for an LC subject heading, then we can do some automatic filtering to get catalogers down to a point where they have to maybe make a choice between 5 to 10 things instead of 5,000 things. So we can use a combination of refinement there. And then we're also using it to supplement places where we have exact matches. So we want to promote some of that serendipitous discovery still. So even if a cataloger has said, here are 5 books that are directly related to this Camp Hale image, then we can still do some promotion that says, hey, we've got another 50 books that might be useful to you. We know these 10 or 3 or 5 are, but there's additional ones that might be useful as well. So our next steps are lots more usability. So we've done a lot of creating mock-ups. We've put it in front of a lot of librarians. Next step is to get working software and put it in front of real users right away. So we've got some of those scheduled over the course of the next couple of months, like Jordan was saying. We've got to work on performance. The more different sources we pull from, the harder it is to do that all performant. We're looking forward to moving to Islandora Claw as soon as it's ready. We've got some refinement of algorithms, a little more linked data entry to go, and then a few more usability studies. So thank you very much for your, wrong arrow. Thank you very much for your time. Wanted to thank the team. Thank Pascal, who's in the audience, who didn't get to come up. So thank you very much.
Okay, thank you, Jordan and Mark. Next up, Monica Maselli is going to tell us all how we can level up and get a job if we don't have one already. Her presentation is called "What Does It Take to Get a Job These Days? Analyzing jobs.code4lib.org data to understand current technology skill sets."
Sorry, I think I went along this title.
I don't know.
On the desktop there.
Okay. Over here.
So PowerPoint, yeah.
Okay,
All right. So who here is actively either looking for a job or perhaps looking to hire someone for a job? All right. And this isn't a, I'm not trying to get myself a job. I have a job. But just curious to see how many people have looked, sorry, I'm a pacer, as you can tell. My students always complain about it, so I will do my best to stand in one place. So how many of you have looked at the jobs code4lib site? Occasionally, and I will make the assumption that we've all seen the job listings come across the code4lib listserv before. So you're probably familiar with some of the sorts of data that I'm going to be talking about today. So as I was introduced, my name is Monica Michelli. I'm an assistant professor at Pratt Institute. Back in the day, I was a web developer. I think I have come to terms with the fact that I am an educator today, but I do try to work a lot of technology into what I do. And part of what I do is manage the technology curriculum at Pratt Institute School of Information. So I am kind of on the front lines as far as trying to shape the next generation of information and library science students to have these skills that are actually going to be useful out there in the real world, as they call it. So this all started when I was tasked with, hey, just add some new technology courses to the curriculum. So I had a list of probably, 500 things. So I'm a researcher, I have a research background, so I decided to be a bit more formal about this, and I did quite an in-depth study looking at curriculum of all ALA accredited programs, looking at the tech courses offered. Then pretty soon into that I realized, well, what does it matter what we're teaching if that's not actually what the jobs are looking for or asking for? So I followed that with an analysis of the data from the Jobs4lib site. Practitioners, and we all look like that at work, right? With a little cat tie on. So lastly, I was interested in looking at people that are currently in the field, currently practicing. What is it that you would like to know about technology that you wish you had learned? So what is that kind of gap that you didn't discover until you got out there into the field? And the goal here is to kind of bring this ultimately full circle and inform curriculum so we're creating the right kinds of students to go out there and fulfill these positions. So for my curriculum analysis, I looked at the 56 accredited programs, Myself and a couple dedicated graduate assistants qualitatively coded 822 tech courses. That was quite a year. And at the end of this talk, I'll have some of my citations, which are available through open access. So I cannot even really scratch the surface of the amount of data and tables and other interesting outputs. But just generally, this helped me do things like say, all right, what are some huge areas where we're offering a lot of tech courses? What are areas where we're not offering ones? Are these kind of up and coming? Are they on the way out? And then secondly, when I first started, one of our faculty said to me, oh, you're doing a study looking at curriculum. You know, that's cute. Somebody does that every couple of years. If you have any programming background, when someone says something like that to you, that's kind of a red flag goes up, right? And you say, not on my watch. So this is my attempt at not on my watch. So I have a web scraping tool that's built with Python and Beautiful Soup that is scraping on a monthly basis the catalogs of all these ALA accredited programs. It's been running about a year now. And it will allow me to eventually, over time, be able to understand the trends. So these are just some of the highlights from the past year. So I will be able to, over time, kind of see what areas are there growth in tech courses, where are courses kind of disappearing or being phased out. And they're not always what you would think. And early on into this, when I was having my graduate assistants and myself work on qualitatively coding all these different courses. So these are all the topics that are offered in the Common Information Technology introductory course that really any ALA accredited program is going to have. So this is a whole lot of stuff. And in particular, I was tasked with rolling out new courses and, you know, what do I pick from this list? There are many, many things there. And a word cloud does a nice job of kind of highlighting some of the most important ones, and nothing on that word cloud will be foreign to you, but where do I focus my efforts? Where do I encourage my students to focus their efforts in the future? So that led me to the jobs analysis. And as most of you are familiar with the code4lib site, it provides a web platform for job searching and posting. Attractive site, kind of bare bones. You can explore the different jobs as they're posted, and you can also, if you choose to, volunteer your own time to curating and tagging the posts there. Has anyone done any curation and tagging of jobs? All right, a few of you. I've done a few myself. I felt like I owed it to the data set. So we have kind of an interesting mix of data that is representing the actual job itself. So we have lots of text-based data like title, as well as the description. But then we also have data that real humans have tagged a job with, which obviously can be weighed quite heavily as being a pretty good representation of what that job actually entails. So this tool originally was developed by Ed Summers from the iSchool UMD. He is still very active in developing the actual code4lib site. The whole source code is available. So if you're interested in it from the developer perspective, Ed's been fantastic to work with. I'm sure many of you know him already. But if you're interested in actually working more on the jobs web-facing piece, he's a great person to get in contact with. So what he actually gave me, and this was so exciting. As a researcher, you just can't beat someone willing to give you a fantastic set of data. So that's like my Christmas, I guess. I don't know. So all the data that's collected on that site is available for use. So Ed handed off to me a anonymized database dump, so just the job listings themselves, none of the other data. And essentially that included job title, job descriptions, and then all the editor assigned tags, so all kind of contained in a relational database structure. So I could see pretty easily, you know, what tags were associated with a particular job, as well as the raw text. So then I entered the world of text mining. Anyone into text mining here with R? All right, a few of you. That actually makes me feel better, because then I can maybe get away with speaking authoritatively about it. Anyway, it's super fun. If you're not into it, it's fantastic. Now I have that classic problem where, you know, if you have a hammer, every problem looks like a nail. So now I'm like, let's run it through R, and we'll do text mining on it and see what comes up. Sometimes it's good, sometimes it's bad. In this case, it actually turned out pretty well. So this was a good first case for me. So obviously, with a database dump like that, I had a huge amount of text, largely unstructured. The job descriptions could have all kinds of information about the job itself, but then also maybe the organization that was offering it. So I used R with the TM, which is the text mining package, which is very easy and fun to get up and started with, to look more deeply into this collection of jobs. And specifically, I was interested in, what technologies are being asked for frequently, and not just what technologies in isolations, but what are these kind of clusters or groupings of technologies that we could start to say, okay, if we want to make someone that's going to be a web developer, they should know this kind of collection of skills. This will make them highly marketable. So that was really my goal there, because it's easy to say, oh, there's PHP used or something like that, but what's the context? And the nice thing when it comes to text mining with technology topics is that we have all these weird acronyms and all kinds of things that are very distinctive. So there's no other word that looks like SQL that means something else, so it's actually a text set that is very amenable to mining. I also did a fair amount of plotting to see these, visualize these connections. I'll show you a few shortly. And I also did some clustering. When you have a huge amount of text like that, understanding not just what terms correlate, but what similar collections are there was very helpful in kind of digging through this data. So what you're seeing here is the latest and greatest. My published papers actually covered from 2011 to 2014. This is the analysis I just did a couple weeks ago looking at the 2015 jobs. And just to give you an idea of the scale, there were about 1,000. And just to give you a sense of the top editor assigned tags, anyone know any of these skills up here? What is this, right? So I would bet we have pretty good coverage here of all these. So these are the frequency of editor assigned tags. I use that as a starting point with my text analysis to have an idea of, all right, we have real humans saying these are valuable skills. So let's use that as a starting point to see what goes along with them. These are, again, just for 2015. Historically, JavaScript, PHP, XML, and metadata kind of fight it out for the top 4 or 5 pretty much every year since the data had went back to about 2011, so since that time. And just to give you an idea of how much work the editors do versus what I could extract from the text. So in this case here, you see about maybe 150 editors or 150 tags of a job. And when we actually look at the raw data in R, the word metadata is always number 1, as you can imagine, but it appeared around 1,100 times. So we actually have a lot of jobs that aren't able to be classified by editors quite simply because they're volunteer curators and they're not going to sit there and curate 1,000 jobs every year, probably. But this was a good starting point. So I use those terms to then look at the correlated terms. So for these top ones, JavaScript, PHP, XML, and metadata, all these are generated using the find associations function that's in the TM package in R. Essentially, it looks, you can set the correlation coefficient and it will tell you what terms are closely correlated. So essentially what this means is if a job is, say, looking for CSS, it's pretty likely there's a strong positive correlation that they'll also ask for PHP, MySQL, HTML, and along the way some generic terms get kind of thrown in there that make my life a little bit difficult. Something like experience in particular is difficult in a job setting because it could mean experience. It could also mean user experience. So there were some kinks I had to kind of work out over time with the data. So when looking through these top-rated terms by editors, try to highlight ones that would show kind of a diversity of positions. So starting to kind of work deeper, going from a language that might refer to more of a client-side work, starting to go more back towards the server side. So looking at terms correlated with PHP, you start to pull up other related languages. We start to see web servers, relational database, management systems, so kind of going deeper into the stack, as it were, with terms correlated with PHP. So the metadata one is always fantastic. This one I could actually fit on the screen. Sometimes there are a whole bunch of nodes kind of vying for a position there. And there are some real interesting, a lot of the common standards, but I'm also interested in looking at, over time, things like the little linked data cluster kind of emerging up there in the upper right corner there, if you can see. So I think metadata in particular will be interesting to explore over time. XML wasn't too exciting in this past 2015. We have all the X's, as you can imagine, and looks like they're doing a lot of web-based stuff with XML nowadays. And I have many more of these term correlation plots in the full paper. And just in my last few minutes, so I didn't stop there. Why stop there? Because there's more data out there. So if anyone saw the results of John Burke's survey, or maybe even participated in it, he sent it around to the code4lib mailing list. And he did a survey back in 2015 asking current library practitioners a number of questions around their technology use. Of most interest to me were two questions, one of which was, what is it that you would like to learn? And I take that to mean, this is a technology skill that if I had it right now, this would be a good thing. So I'm very interested in that because that tells me that's a skill that probably should have been rolled into curriculum at some point. And then also what they are doing in actual practice. So one of his questions asked them, well, what are you actually using on a day-to-day basis? And first I took a look at the wants here using clustering to kind of see some of these different topics that emerged. A lot of them aligned pretty well with these skills that are coming up kind of again and again in the job listings. And I also wanted to look at, with their current skill sets, what are these common co-occurring skill sets? So we can say this is one form of technology use. So maybe this is more oriented towards the patron side or the user side. So in this particular correlation, I looked at skills that commonly occur around Linux. That was one of the questions on the survey. I figured if you're using Linux, you're probably on the tech side, I would imagine. And I have time expired. All right. So here's my last slide with my summaries. I'm doing a lot of other questions, kind of digging into this stuff over time. My full papers are up there and available if you want to look more deeply into the different technologies that I encountered. All right. This says 1409. That's cool.
Thank you, Monica. And just so you all know, we are slowly posting the slides to the website, so you'll be able to get all those links that Monica posted at the end. Okay, next up, we have Francis Webb and Jennifer Colt talking about building a user-friendly authorities browse in Blacklight.
Hi, I'm Jennifer Colt, and I'm a user experience developer at Cornell University. And yeah, we're going to talk about the authorities browse that we've been building in Blacklight. We recently, well, over the last couple of years, moved the public interface for our catalog from Voyager to Blacklight. And one of the things that we needed to do when we did that was replace the heading search and browse that had been part of Voyager. So to give you an idea of where we're starting from, here's a subject browse in our Voyager interface. I was looking at science fiction. You can see that there's 13 entries for it. And so here's the same browse in Blacklight. And it's only showing up twice now. In the Voyager version, we were listing the term according to vocabulary, so it ended up showing up many times. Here we're showing it according to what field it appeared in. So you've still got a choice to make, but hopefully it's a little bit easier. And you've also got some easy access to the narrower terms related to science fiction. This is the author browse in the Blacklight interface now. And you can see that I'm looking at Carrie Brownstein, and she's there along with the C also for Slater-Kinney. And both her name and Slater-Kinney are linked because they will go to a search result in the main Blacklight catalog. A couple rows down, some people can see, there's Daniel J. Brownstein, and his name isn't linked, but his C to Brownstein Dan is linked because we don't have any search results for the first version of his name, but we do for the second. So we've tried to avoid creating any dead ends. There's no, headings only appear here if that heading or it's C or it's C also will give you some search results in the main catalog. So if you click on Carrie Brownstein, these are her search results, just a couple of them. And then when you look at an item, if there's an authorized version of the author in the field there, a little info button will show up. And it's going to bring up a box with biographical information if there is some. There wasn't much for her, as well as some search links for the works by her, the works about her. The C also for Slater-Kinney comes up again, and if you click that, you'll be able to get the search results for them. So that's sort of the obvious interface integrations that we made, and Francis is going to talk about some deeper stuff.
Hey, so I'm Frances Webb. I'm another developer at Cornell. And so there are a few kinds of cross-references that we have in the browse, but I want to talk about the C references a bit. The C references are different because we're telling people, we think you're searching in the wrong place. And in this case, we in fact have no catalog records that list heart attack as a subject heading because that isn't the preferred form of that term. So this is really vital information to expose. Unfortunately, in this case, what we've done in the browse, while it makes the information available, it doesn't quite help if somebody just comes and does a subject search for heart attack. They won't realize that they're missing something, or they may not. So the cross-references come from the authority record. And as of 2015, if you were to do that subject search for heart attack, you would find nothing in our catalog. As of 2016, you get this, which is arguably a more satisfactory result. And so what we've done now is we've taken, for every bib record that uses a preferred form of an author, contributor, or subject heading, we have pulled in all the alternate forms of those headings and made sure that that bib record is findable using the alternate forms. This just went live at the beginning of the calendar year. It's been very successful so far. None of these records have heart attack as a subject heading, even though this is a subject search. So this is the first hit. You would have found this record in all fields, a general search for heart attack, not a subject heading search. And this record is the second hit. In fact, doesn't contain the word attack anywhere in the record. It's still a very, very appropriate result. So this we're hoping to be a very subtle difference, that people will find the records they want, but they won't necessarily realize that we've done anything interesting to allow them to find the records that they want. And one of the things that I like about this particular integration is it's something that could be adopted without needing to set up an entire browse, as long as the piece that is doing your indexing of bibs can make the retrieval, can query using the preferred headings to retrieve the alternate forms, then this is the kind of thing that should be doable. So indexing the authority records. There are a lot of systems that already do this. Our first step was to index the entire authority file. This is both name authority and subject heading authority into a single MySQL database. We assigned our own IDs to everything because the authority record doesn't assign identifiers to alternate forms. And in order to make a really good mapping of all the cross-references, we needed things to have identifiers. If you are thinking of doing your own indexing of the authority file, beware the undifferentiated name records. One of the risks of reconciliation is that you will merge records for two different people accidentally. The undifferentiated name records have done it not necessarily willingly, but deliberately. It's known they're labeled beware not to trust the alt forms because you don't know which of the people they refer to. So once we've built our database of headings that appear in authority records, we index the headings that appear in the bibs. And this is 12 different queries that go into our Blacklight Solar Index of bibliographic records, retrieving information about what headings appear, how often, and in what fields. And we add that information to our existing heading entries in our database, and we create new heading entries for things that weren't already in there. Finally, we push all of this from our database into Solar. As Jen was explaining, we don't push authority records that we don't have anything interesting to say about as far as our own content. And you can see we drop about 2/3 or 3/4 of the authority records in this move, just because we don't have that kind of coverage. So I've been asked why it's a good idea to go to the effort to build a separate index for browse versus trying to pull the summary data from Solar, which is something that Solar can do, but Solar is a lot stronger when you're trying to pull information at the same granularity level that it's indexed. So our Blacklight index is indexed at the bib level. This is indexed at the heading level. And it gives us a lot of additional capability. So the only other thing I wanted to talk about is filing, which doesn't sound exciting. Everybody knows that you need to, well, you will experience, if information is not normalized before a system tries to sort by it, it becomes very obvious because all the capital letters sort before the lowercase letters and the diacritics mess everything up. What we're doing here is a little bit more complicated because we have decided that if two things normalize to the same sort value, they are the same thing. So in this case, a few minor changes in punctuation, capitalization, don't actually constitute a different heading in our indexing. In this case, we had to do something a little bit different because we have a difference in the headings that we want to be reflected in the sort, or we don't want to be reflected in the sort, but we do want it to be reflected in the filing. These are not the same heading. And finally, we have this Dutch East Indies. The Dutch in the East Indies are not the Dutch East Indies. And both of these headings actually do appear in our catalog. The zeros force a sort pivot, which means we sort first by the main heading, then by the subdivision. You can see in this browse, everything that relates to Prince, either the individual or the concept, comes before Prince Albert and everything else. And this is especially vital in this view where you would never be able to find in our author title browse the Prince works if they didn't sort first. So, and we have code references.
Francis and Jennifer. Next up, we have making new discoveries from old data, utilizing digital scholarship to foster new research in special collections. And that's by Matt Carruthers.
Hello, everybody. I'm Matt Carruthers. I'm from the University of Michigan. I'm going to talk to you briefly today about some of our recent efforts in the library towards utilizing digital scholarship as a way to foster new research in special collections. Link to these slides at the bottom. I also posted the link on the Slack channel just in case there are heads in the way. Just a bit of background to start off. A few months ago, a small group of us in the library were brought together to explore using digital scholarship methods and technologies to enhance user experience in special collections and potentially even provide new services. And in terms of a charge, that was all the detail we got. So it was kind of wide open in terms of where we could go. So we decided to start off, we would talk to some patrons, some staff, get an idea of where we were falling short in terms of discovery of our data or providing access to our data, and use that as the basis for developing a proof of concept for a new service under a couple of operating principles. First, use existing open source technologies whenever possible so that we can cut down on the need for in-house development. And second, hopefully develop a service model that would require little to no need for dedicated IT support over time. So essentially, it would be something that special collections staff could run start to finish in-house. What we came up with, and again, this is still in the very early stages, but it's a proof of concept for a service to provide visualization on demand, customized to a patron's individual research question. So we would use data that we already have as the basis for this in the form of our EAD finding aids, combine that with some open source digital scholarship tools to create interactive visualizations of the social networks or the network graphs of the creators of our archival collections. Again, customized to exactly what a patron wants to look at. So all of the people, organizations, and things that our collection creators are connected to somehow. The idea behind this would be to make these connections between entities much more apparent, because often they're either buried within the finding aids or scattered amongst a lot of different resources, so it's difficult for them to find. And we can provide these visualizations as a discovery tool to the patrons to help them further their research. So as I mentioned, I'll take you through a little bit of the process that we've developed so far. It all starts with the EAD files we already have, and we start by extracting the information about the creators of those collections from the EAD files and using that to create EAC-CPF files. EAC-CPF stands for Encoded Archival Context for Corporate Bodies, Persons, and Families, and it's essentially meant to be the companion standard to EAD. So EAD describes all of the archival stuff. EAC-CPF describes the agents responsible for creating that stuff. And the really neat thing about EAC-CPF as a metadata standard is you can actually encode relationships between the subject of the record and other entities and describe the nature of those relationships in a machine-readable format. So that's the data that we're really looking to take advantage of here. So in terms of creating the EAC-CPF records, we actually have a few options available for helping us automate that process. I don't have time to go over all of these in detail. You can follow the links for more info. Suffice it to say, these are all services or tools that are openly available to automatically create EAC-CPF records based off of your existing EAD files, and then it gives you the option to enhance those records by pulling in additional information from various APIs like VF and WorldCat. So once we have our corpus of EAC-CPF files for all the creators of our archival collections, we run it through, or we run the files through a very simple XSLT style sheet that we put together to extract the relationship data from those files and put them into tab-delimited text format that we can use to put through our visualization software. So once we have the tab-delimited text files, it's just a question of actually having a reference interview with the researcher who's interested in looking at or building a custom visualization, looking at a subset of our data. So we figure out what their research question is, work with them to decide exactly which files and what subset of their data they're interested, or our data they're interested in looking at. So what we're pulling out in terms of the XSLT style sheet and putting in these tab-delimited files is 4 bits of information. The name of the entity that is connected to the subject of the record, the type of entity that it represents, and we use 5 basic entity types, the type of connection that exists between those 2 entities, and we use 4 connection types that were originally defined by the Social Networks and Archival Context Project, and then when it's available in the record, a link to an external web resource that provides more contextual information about the entity that's being represented. So once we've got those text files, we can actually move on to the business of visualizing all this data. And we looked at a lot of different platforms, everything from D3 to Gephi. And we decided in the end that Cytoscape was the tool that worked best for us. It's an open source desktop application out of UCSD designed for visualizing complex network graphs. So this is a screenshot of what the interface actually looks like. The visualization that you're looking at here is actually one for the social network graph for all of the creators of our children's literature collections. And the cool thing about Cytoscape is you can define a custom style file to determine the layout, color coding options, things like that, and you can import it into any data set that you want to build a visualization for, so you don't have to do the same thing over and over again. So if you can see there, the red nodes represent the entities that were the collection creators for the collections we have locally. All of the white nodes are other entities that they're related to, and then the connections, the actual edge lines, are color-coded according to the connection types that we have defined. So the other cool thing about Cytoscape is that you can very easily break out subnetworks from the larger whole. So if we wanted to, for instance, have individual visualizations for the first-degree network connections of all of our collection creators in here, we could actually, with 2 or 3 button clicks, break out a subnetwork. So we can produce a lot of visualizations very quickly for the patron. And it usually only takes a few minutes to go from selecting the text files to use to spinning up these visualizations. It's very quick for us because all we have to do is import the data files, import the style file that we already have defined, and that's pretty much it. The thing is, we didn't want to rely on the desktop application as the way of sharing this with our users that requested these visualizations, because that would either mean they would have to be in special collections and use our machines to look at them, or they would have to download their own instance of Cytoscape, and we didn't want to make them do that. Luckily, Cytoscape has kind of a companion platform designed for web publishing called CyNetShare. And this is the point where I could actually link out to these and show you a working example, but I don't trust my luck going forward with the Wi-Fi holding together. So I'll stick to screenshots for the time being. So to use CyNetShare, it's actually really easy. It's hosted, again, by UCSD. All you have to do is export the files that for your visualization from Cytoscape, and it gives you a JavaScript file for your data, a JSON file for your style elements if you choose to create custom ones, and you put them anywhere on the web that gives them a public URL. GitHub's an easy solution. You could use your own website if you want. Put the URLs into the form, click Visualize, and you get a fully interactive web version of the visualization that you created in the desktop interface, complete with the ability to generate a nice short little URL that you can simply email to the patron that requested this so they can look at these visualizations and use them anytime, anywhere from the web. And this is just a screenshot to show you a little bit of how you can interact with these visualizations. They're zoomable. You can actually click on different parts of the visualization and drag to manually reformat if you want to move different elements around. There's a table available, so if you click any different portion of the visualization, you can get more textual information about what's actually being represented there. So it's a pretty malleable interface. So that's where we are right now in determining our service model. The next step that we want to do is continue to streamline the workflow as much as possible. Like I said, it only takes a few minutes to spin up each one of these on average. It depends on the size of the data set a little bit, but we want to make sure that it's as easy as possible for the staff that'll actually be, at least in theory, running this service. Then we can move on to performing some more robust user testing, performing actual pilots with real patrons and working their feedback back into our service model. And then we can start to explore more options for using and manipulating the data. CyNetShare is also open source. It's built off HTML5, uses the Cytoscape JavaScript library and a little bit of AngularJS. So we could actually install and host our own version of that if we wanted to have permanent visualizations linked to from our Special Collections website, and then use the hosted version at UCSD to publish the on-demand visualizations that we get requests for from patrons. So that's all I have. Feel free to contact me if you have questions or track me down. I'll be at the conference all day today and tomorrow. Again, slides at the bottom or on Slack. So thanks very much for listening.
Wow, that was so well timed. I think he finished with 1 second left. Okay, we have one more talk of the afternoon, and then we'll wrap it up. Kim Pham is going to tell us about, talk to us about curating my web crawl, building a multi-processing web crawler for ethnographic research.
Hi, everyone. My name is Kim, and I'm a librarian at the University of Toronto Scarborough in the Digital Scholarship Unit. I'm here to share our experience so far with building MediaCat. It's a web crawler application which was made possible through a partnership between our university's Department of Computer Science, the library, and faculty member Dr. Alejandro Paz in the Department of Anthropology. So this project began with a research question posed by Alejandro and exemplified here in this quote. If we acknowledge that current mobilizations of public opinion transgress geographic and political boundaries, we begin to see patterns of intertextual and interdiscursive dialogue that forms these public spheres of communication. Alejandro studies mass forms of communication, such as online journalism, to see how they inform these global public spheres, but with a specific focus on tracking how Israeli news is being produced and disseminated online, and how that news is being recirculated in English news or social media. He began his research 2 years ago by interviewing journalists in Israel about the textual practices of creating news, but he also wanted to look at the actual news content that's being produced. Studying this quickly became complicated, so that was when he came to the library to see if we could help him realize his plans of gathering and analyzing large amounts of articles on the web. So Kirsta, our Digital Scholarship Unit coordinator, reached out to a computer science professor, Dr. Anya Tafliovic, who thought this sounded like a good project for her upper-level software engineering course. And that's really how this project and collaboration began. Last January, we had students working in teams to develop personas and to gather not only Alejandro's requirements, but also the requirements of the library. The idea that once the course was finished and the application was developed to a point of maturity, we would adopt their app baby and continue to maintain it and develop it further. So throughout that semester, we came into the course working with computer science students to flesh out their requirements and turn them into use cases. From our perspective, we wanted an app that uses open standards, something that could be modified and understood by others, and also keeping it open provides the added benefit for the students to have code that they could publish and point to on their resume. The crawler should accomplish the objectives of Alejandro's theoretical approach to collecting data, but should also be sufficiently generalized so that it could serve a broader community of researchers and students. Anyone should be able to benefit from using this app, regardless of their technical proficiency. Ideally, you should be able to build your own personal web archive with minimal interaction with code. You should also be presented with a variety of export options, depending on your comfort level, to manage your own data sets. We also wanted to make sure that we would be able to provide sustainable support in using this app. So thinking about a post-grant or no-grant scenario, if we didn't have access to high-performance clusters, we could still support multiple users to get meaningful data out of the system. So instead of going with the approach of amassing large amounts of data, we wanted to focus on building unique data sets that capture only what is needed. So once the course was finished, a smaller team was formed in the summer to continue working on this project, and we've been working on it ever since then. Love these guys. I won't do a demo, but I will quickly run through the basic functions of this app. So MediaCat is written in Python and uses the Django framework as its front end, which you might know Django was originally developed by two programmers working for the Lawrence Journal World News and was designed to manage news-related data. Django, out of the box, provides user authentication and comes with an administrative interface that the library could use to provide user accounts to students and researchers. From the interface, you could also stop, pause, and start the web and Twitter crawling processes. To define the scope of a crawl, a user inputs a list of referring sites such as the New York Times or BBC.com, which you would do from the screenshot here. And so you would end up with a list of referring sites that will be crawled and archived. The referring sites, however, are constrained by your source sites and keywords and their concordances. So which means that if only in a page of a referring site, if there's a match for a source site or a keyword, that page will be archived. Otherwise, it won't. We also have You can set up the same scope for Twitter accounts, so you can set up a list of referring Twitter accounts, looking for mentions of source Twitter accounts and keywords as well. So MediaCat comes with an installation script that installs its dependencies and reads from a configuration file shown here that you would use to set up your directory structures, set up Twitter keys and storage formats, and also set up your crawler rates. MediaCat uses a number of existing libraries that help us tackle some of the features that we wanted to get out of a more curated crawler. There are two separate crawler functions. One process looks at recent RSS feeds, and then we have another crawl process that scans multiple domains at once. In addition to looking for keywords, we make the crawler more efficient by using readability. It's a Python library that parses and scans only the relevant sections of a web page, which saves us some crawl time by ignoring content such as ads and sidebars and menus. If there's a match, we extract the relevant sections using newspaper, a more robust extraction library that uses natural language processing to identify common article structures. So right now, it recognizes things such as title, author, keywords, date fields, which can be indexed and searched on. At the same time we capture text, we also capture an archival copy using wpull to store works, as well as PDF and PNG screenshot copies using Phantom.js, which is a headless WebKit that will render a page as if it was being loaded into a browser. This provides us with a simple workaround to archive AJAX or JavaScript-heavy websites. A lot of work still needs to be done, and only recently we focused on doing more test crawls to check on the quality of the data. By doing these repeated crawls, we've noticed some interesting outliers and issues with duplication of the content. So, for example, in a few particular web domains, some fields weren't being captured. Domains structure their sites differently using their own tags and unique classes, so the newspaper API doesn't always pick up on the right fields to extract. In these situations, we get users to add CSS selectors from the source of the web page, and that's where they can input the fields that they want to capture with the appropriate field heading. So our new pipeline for our crawler now is to check if there's input for CSS selectors on a domain. If the selectors return nothing, that website is scanned using readability, and if there's a match, the content is then extracted with newspaper. In cases where editorial policies controls how content needs to be formatted or cited, this increases the complexity of comparing data between different news sites. We've seen situations where a source is mentioned in an article, but again footnoted at the bottom, or sometimes they don't link to the source article at all, which, as we're tracking mentions, they will be counted differently. Sometimes we get relative URLs that refer back to the same page. Usually when we're crawling the URL, it can be normalized using a Python library. With more common cases, like the first two links, this normalization works. But for instance, in the second two cases, although it would link to the same page, the crawler treats them as distinct URLs and crawls them again. Canonical URLs that are written into meta tags can also be inconsistent. They don't always take into account article pagination, so sometimes you would only capture the first page and not the entire article. The alternative to this would be to crawl the site and to capture redundant pages and then figure out a way to weed them out later. We haven't come across this issue yet, but we are aware of the fact that certain URLs can restrict access to content to certain users, and this will also later affect the way that we would do our crawl. So as we're going through and documenting some of these issues, I just want to mention that we're trying to avoid hard coding a lot of this logic into the system. Instead, we'd like to make entering in these URL patterns configurable in order to maintain some flexibility in the system, in the hopes that this will support the curation aspect of web crawling and allow researchers to continue to iterate and adjust their queries to get the data that they need. If you want to learn more, you can find the project, which is open source and is available on GitHub. And if anyone's doing similar work, I'd like to hear from you. Thanks.
Okay, that does it for today. Mind blown. Lots of good stuff. We will be back here tomorrow morning for our second keynote by Gabriel Weinberg. And just wanted to mention that some details for the Play and Share are posted to the schedule on the website, the conference site now, so location and times and everything. And any requests, you can tweet them out or Slack them, and we'll see what we can do. That's also the game room. It'll be in the Hamilton room. And one last thing, I just want to thank our contributing sponsors really quickly as you're putting your stuff together because they deserve it. All of our sponsors do. And let me just pull them up here so that I can read them off. Oh, cool. Watch live stream. Nice. Okay, contributors, Balsamic, Azavia, thank you. Library Help, Illinois Institute of Technology, Simmons School of Library and Information Science, University of Oregon Libraries, UNC School of Information and Library Science, Drexel University Libraries, the University of Texas at Austin School of Information, and there was one last one that we didn't quite get up here. We will get that before the end of the conference, but Vail, the New Jersey Library Consortium. Okay, thanks a lot, and we'll see you tomorrow.